Audio is available for this presentation through your computer or by telephone. Please keep your microphone muted to avoid any background noise and feedback. If you have any questions during the presentation, please type them into the chat box. I also will provide a link as well for questions and answers for the presentations, since we do have a pretty jam-packed agenda. And so if questions come up later on too as well, you're able to put those questions in the comments in the link. We have a dedicated time and answer some questions at the end of the segment, or actually that's the part that we're kind of cutting out. We're going to be having a town hall meeting. And so this is something new that's going to be integrated from Dana. And so we have a full morning of presentations, different topics. And so if you're experiencing any technical difficulties, please contact us through the chat box and we'll try to troubleshoot the issues. There is closed captioning available on the bottom left of your screen. And then we'll also post this presentation and slide deck on our website after the meeting. And so it's nice to be here today. Good morning, everybody. And thank you for being here today to the DUS Symposium. We're going to have a full morning of topics ranging from research, forecasting, mitigation, as well as health information. And so I'm always excited to be here for hosting these DUS Symposiums for the past 3.5 years. And so those who don't know me, my name is Armando Paz. I'm with the Air Quality Bureau with the New Mexico Environment Department out of the Las Cruces field office. And so my job duties entail working with the dust mitigation plan, as well as submitting exceptional events reports for PM10 exceedances, or exceedance of the National Ambient Air Quality Standards. So those are annual reports that are submitted to EPA for those exceedances due to our high wind blowing dust events. So we're right here in the thick of the dust area. I like to refer to it as the dusty south, because we're right in that band. Whenever the conditions are right, we get a lot of sand whipped up from like the southwest part of the continent. It's kind of a somber moment here to kind of reflect on the tragedy that happened last Monday, May 1st, in Illinois, with the big dust pile up car crash that contributed to a dust storm. So this is kind of a new type of thing in that region of our country. So it's kind of I guess you can say nothing really new for us down here in the southern part of New Mexico and Arizona region. We have a pretty bad area that's along the border of Arizona and New Mexico. So we did have an incident earlier this year that entailed an accident with some injuries. So I mean, we're wanting to come together and be able to provide a platform for our research and just be able to touch base with some of the folks who are really the forefront of this research, forecasting, as well as mitigation. So I'm pleased to be here and honored to be able to present and host this symposium. So I'm going to go ahead and get started with our first presentation, and it's going to go ahead and it's going to be Joe Delizio with our El Paso National Weather Service, and he's going to be presenting about a comparison between 2 late February dust events. And so, Joe, go ahead and take it from here.
Sounds good. Let's see. Let me share my screen here. Can you all see my presentation? Can you see it, Armando?
Yes.
Okay, great. Like Armando said, I'm Joe DeLizio. I'm a meteorologist at the National Weather Service in El Paso. So we're just going to do a quick little comparison of the two late season or late February dust storms. So just a quick little dust climo for basically the El Paso area. This is a dust event monthly frequency distribution, and so just basically the bar graph shows the number of dust events here from the southwest wind direction, and the shaded brown is any wind direction. And so a majority we do get from the southwest, but they can come from any direction really. The one thing to note here is we have a little bit of a peak or a maxima during the fall season, but really our main dust events occur late winter into the spring time frame. And so the fact that we had two dust events during later February is not too uncommon, but we definitely do get more occurrences in March and April during the heart of the spring season. I'll try not to do too much of the meteorology here, but this is the upper level pattern on the 22nd of February. And so we have the upper level wind shaded here in the reds, oranges, and pinks and purples. And so the purples are the strongest winds. And then the heights, basically where we can track energy or trophiness, are these black lines here. And so one interesting thing is that it's a very sort of broad trough over the southwest and basically the western U.S. And the strongest wind speeds aloft generally pass just to the north of El Paso and southwest New Mexico into central New Mexico. And so that is definitely a strong wind pattern, but you'll see, and potential dust, but you'll see a little bit different than the 26th. At the surface, we do have a cold front moving through during the afternoon hours, pretty typical of potential strong winds and dust. And so when we compare that to the 26th, the one thing you'll notice here is it's a much more compact system. You can definitely see it's not quite as broad, and the strongest wind speeds are generally right over southwest New Mexico and right along some of those dust source regions in northern Chihuahua. So a little bit different overall pattern in the upper levels, but still a strong wind producing system. And in the surface, the same sort of thing. Different orientation of the cold front, but still a cold front moving through during the midday to afternoon hours. So there are some differences and some similarities. Some of the similarities where we had two strong wind events basically on the 22nd and the 26th. So the 22nd, some of our max wind gusts, a bunch of 50 plus miles an hour, some 60-mile-an-hour readings, Deming and near TRC and in some of the mountainous areas. And then arguably on the 26th, slightly more impressive event, we had 70 miles an hour in Las Cruces, TRC, Deming, and El Paso, and then 70s to 80s in the Sacramento Mountains. So slightly different patterns, but they both produce strong winds, just a little bit stronger on the 26th. And so with the wind does come the dust, and so this is just a comparison from the late morning through the afternoon hours of the dust here. And this is the dust RGB satellite, and so 22nd is on the left-hand side, the 26th is on the right-hand side. So you can definitely see that they're the brighter pinks and the more widespread kind of spatial significant dust definitely occurred on the 26th, just 4 days later from the 22nd here. But you can still definitely see some plumes here on the 22nd across El Paso and off of White Sands there as well. So just to kind of confirm that at the surface, here's the 22nd, the visibility is here, and so one of those plumes produced about 4 to 6 statute miles of visibility here on the 22nd. 26th, it was much more significant. You were down to 1 to 3 miles, in some cases below a mile. So I really wanted to investigate why 4 days later the dust was much more significant on the 26th versus the 22nd. And so we saw some differences in the meteorological pattern, but I went back and looked at the soil moisture as well. And so the 22nd is on the left-hand side, the 26th on the right-hand side. And if you just kind of eyeball it here, and again, this is just the basically surface through 10 centimeters below the surface soil moisture percentage. And so you definitely see some more greens and yellowish colors kind of to the south of the international border of Arizona and the boot heel of New Mexico. And just generally eyeballing it, you can kind of see there's a little bit more of these warmer colors. So generally drier overall. What's the data source? I think this is SMAP. Forget where I pulled it from exactly, but basically the percentage of the soil that is has moisture in it. And so I did a quick little difference map here, 22nd versus the 26th. And anywhere you have these warmer colors here south of the international border is where you do have drier soils on the 26th versus the 22nd. And so again, we had strong winds both days, but a little bit drier soil. I do think that's one of the reasons why it was a bit dustier on the 26th. Additionally, we have a composite or a conceptual model meteorologically of a dust storm for our area in El Paso. And if you kind of remember, again, these are the upper level winds and the upper level heights. And so if you remember, the pattern on the 22nd was a very broad trough, whereas on the 26th, it was a much more compact system. And then this is a mean of 21 events or a median. And you can kind of see that it has a little bit more of a compact signature, and the strongest wind speeds are further south and right over El Paso and northern Chihuahua. So if we look back to our 26th event, it lines up pretty nicely. Of course, the wind speeds aren't the same because one's a median and one's a mean, but overall, our conceptual model of significant dust storms in El Paso meets or is pretty similar to the February 26th event compared to the 22nd. Whoops. So I just wanted to quickly touch on some of the dust storms. The only archive data I can get a hold of relatively quickly was the RAP Chem model, and it does a pretty good job overall showing the larger spatial extent and more significant dust storm on the 26th versus the 22nd. But oddly enough, the surface visibility during the same time frame is not reduced much at all, except for maybe one of these right near the dust source region south of El Paso in northern Chihuahua. So I'm not really a dust model expert, but it's kind of confusing why the surface visibility didn't decrease all that much in the model, even though it showed a lot of dust emission, surface dust emission. So if anyone has any questions or has any comments about that, feel free to reach out. So I'm no expert, but just interesting to note that the visibility on this dust model didn't really decrease in our area. I have this dust analog here that I presented on a few years ago at this symposium. And basically it takes the surface wind direction, wind speeds, and max temperatures at different airports and goes back in the past and compares them and then spits out the min visibility. And so I just wanted to show here another kind of tool that we kind of use to forecast visibility here. And this is for the February 26th event. And so at El Paso, it showed a good 70+% of less than a mile visibility potentially. And so this doesn't really take into account soil moisture or really anything other than surface variables, but I am working to kind of make it more of a gridded data set. And so just another tool we kind of use to try and forecast visibility, which is extremely difficult. Again, if you have any questions on that as well, you can ask me. And kind of it came to my conclusions here. We had two impressive wind events later February and dust both days, but it was more impressive on the 26th. Again, I think the subtleties in the meteorological pattern, like I showed on the 26th, the winds were further south across northern Chihuahua and southwest New Mexico, in addition to the drier soils and really drying out from the 22nd through the 26th. I think that's really the reason why we had a more impressive dust storm on the 26th. But again, I'm open to questions and comments because this is just my observations here. And it looks like their dust density visibility forecasting is still extremely difficult. especially with some more of those local uh, kind of source regions. And so just a quick note about that there, and I'm trying to make some tools that will kind of help us with that. But as we saw, it's very important to kind of try and forecast some of these local areas as well, potentially. That's all I have. Questions, comments. There's my email there if you want to um, email me any sort of questions or anything like that. So that's all I have there. I think, let's see, I'll stop
Yeah,
sharing.
I think we had a couple questions from Xingzi, and he is asking what is the data source for the 0 to 10 centimeter soil moisture?
Yeah, I think that was the NASA SMAP data, I think. I got it from a website. Um, so I would have to really go back for a second and check, but I think it was since it was experimental, I think it was the from NASA, the SMAP kind of site.
And then the other question that Xingzi had was, did you look at the at 2 meter temperature changes, and then were the dust storms triggered by cold air outbreaks?
Yeah, so typically, I can kind of go back and see the cold front kind of feature. They were kind of similar as far as max temperatures, I think. I think one of them, let's see, I think the 26th was a little bit warmer generally. I think we were in the 70s versus like the 60s on the 22nd. So a little bit warmer generally. The warmer you are, the easier it is to kind of loft some of that dust and the higher your boundary layer is. And so, but generally we do get sort of these cold fronts in behind when we get dust. And so, yeah, I do think that right along and ahead of the cold front typically is when we do sort of see our dust, and then behind that is kind of a cooler air mass. So definitely makes sense, but the dust forms in the kind of the warmer temperatures. Okay, there's a period after rain.
Great, thanks. And then we had a comment from Glenn later. He said, "Nice presentation, Joe. We observed similar trends with the dust in Arizona. There's a period after rainfall where the soil moisture increases just enough to mitigate blowing dust. The difficulty is understanding and quantifying how much soil moisture increase is needed in the duration."
Agreed. Yeah, it was really interesting to see only 4 days later after we had rain in some areas where um, you had such a like a minor dust event and then a more significant event just a few days later. But and we were all at the office. We were kind of really scratching our heads wondering because just 4 days ago we had a really strong wind event and just kind of a minor dust event. But uh, we had the same sort of look, but we were wondering, is it going to dry up enough? So yeah, definitely agree with your statement there, Glenn.
And then Susie wanted to thank you and just mention that it could be a prefrontal event.
Yep, agree.
Okay, so is there any other questions or comments for Joe?
Can you say about small events? Are they sometimes as impactful as the large events, or is the public more aware? What I could say about that is sometimes we have smaller, more localized events. I'm sure a lot of us are aware on the Lordsburg Playa, and that's where we had one of our deadliest events. So I don't think it really matters about the scope or how large the event is. If it's a relatively narrow area and it reduces visibility rapidly, I think it'll cause a lot of major impacts. And that's what we kind of saw, right, in Illinois a few weeks ago or a week ago or so. And so I think typically, honestly, I think the smaller events are a little bit more impactful overall than the larger events, unless we have a really, really large area of like a quarter mile visibility or lower. Um, but we put out these warnings and stuff, but I do think down here it's kind of a way of life, and the public kind of just knows that the spring is going to be dusty, as potentially dangerous as that may be. But yeah, I would say that some of the smaller events are honestly more impactful than some of these larger events and systems.
Great.
Hmm.
Thank you, Joe, for that presentation. That was great. Um,
Thanks.
yeah, I don't know if anybody else has any other questions or comments.
I don't see anything in the chat,
Okay.
Armando.
All right. So we can go ahead and proceed on to our next presenter. Our next presenter is Guillermo Rodriguez Ortiz. He's from UTEP, University of Texas at El Paso. And he'll be talking today about the optical properties of alien dust in El Paso, Texas, from high temporal ground-based measurements. Okay, Guillermo, sorry to see here. Presentation mode.
Hello, everyone.
Hello.
So thank you for the introduction. So pretty much I'm going to talk about the optical properties of the alien dust during dust storms in El Paso. So as introduction, I can say that El Paso is located within the Chihuahuan Desert, as you may know, and it averages around 15 dust events per year, where dust is advented from sources up to 200 kilometers upwind. Here we have like two dust periods, which will be the dry season and the monsoon season. So the dry season is from November to May, and synoptic scale dust events are pretty common during that season. While the monsoon season, we have more mesoscale convective dust events. So here in the picture in the right, we can see that a typical like dust event in the Chihuahuan Desert, we have some dust plumes over the northern Chihuahua. So the measurements were taken from two adjacent locations in spring of 2021. One was the TCEQ CAMS 12. The other one was El Paso black and brown carbon measuring site. So El Paso BC square site comes with two instruments, the nephelometer, which measures the scattering and backscattering coefficients, and two tricolor absorption photometers, which measures the absorption coefficient. These instruments work at three wavelengths, blue, red, and green. And from the TCEQ side, we got the PM10 and PM2.5 and wind speed data. All this data was taken at 5 minutes resolution. So with the data taken at the BC square site, we compute some important optical parameters such as the absorption and the scattering Armstrong exponent and the single scattering albedo. The absorption Armstrong exponent, or the AAE, is an indicator of the aerosol composition. So it's very useful to identify the type of aerosols that we're having. For example, black carbon has values around 1, while dust has values around 2 or 2.5. While the scattering Armstrong exponent tells us the particle size, or is an indicator of particle size. For example, SAE values close to 0 means large particles, and the other way around. And the single scattering albedo tells us the contribution of the scattering and absorption to the total light extinction. For example, SSA values close to 1 tell us that the aerosol is of a scattered nature. So here is the big question, how we identify dust events. So as you may know, we have different ways to identify dust events depending on different constraints that we could put on, like for example, visibility. Here we use three constraints. The first one was we look for days with PM10 concentrations higher than 100 micrograms per cubic meter. Also, we look for wind speed greater than 10 miles per hour. And we look for SAE values smaller than 0.5, meaning that we're looking for big particles. So here I have an example of the raw data As we can see, we have PM10 levels above 100. We have SAE values smaller than 0.5 and wind speed greater than 10 miles per hour. So after we put that constraints, we identify in total 25 DOS events. Out of these, 14 were synoptic and 11 were due to convective processes. So as you see, as we are getting closer to the monsoon season, we are getting more and more convective DOS events. So after that, we wanted to classify the type of aerosol that we have during those events. We use this classification scheme by Schmeisser et al., where they use the optical properties of the aerosols. So pretty much they use the absorption and the scattering Armstrong exponents to like classify the different aerosols that we can have. So based on that classification, we classify our dust events as large particle with black carbon mix, most of them, which was a little bit like interesting because we didn't find like any dust event that fell into the category of dust. It could be due to the pollution, or it could be the properties of the dust, the composition, for example. So after that, we wanted to establish a source-receptor relationship via back trajectory analysis. For this, we use the high split model, and the data that was the input was the global forecast system at 0.25 degrees. All the parameters were set as default, and the runtime was 24 hours. We have in total 24 back trajectories in a ensemble, and the height was 500 meters above ground level, where the planetary boundary layer is. So here I'm going to present you 3 case studies. So first I wanted to show you this picture, like it's the same view, but like under normal conditions and during a dust event. Now, so the first case will be on April 26th of 2021. Here we have 2 dust events during that day where the PM10 maximum values were 150 and 250 micrograms per cubic meter. The AAE ranged between 1 and 1.5, meaning that it fell into the category of large particle with black carbon mix. The SAE values were close to 0, meaning that we had big particles. And if we see the high split back trajectory, we can see that it crossed major dust sources areas in northern Chihuahua. This is very typical for synoptic dust event. Now, in this graph, we can see that like around 1 a.m., the PM10 values increases more than 100, and then at the same time, we have a decrease in the SAE values. So after the dust event is over, we can see like normal conditions on the optical parameters. Then in the afternoon, we have another dust event that lasts for almost 5 hours. So here we can see the same pattern. We can see that the PM10 levels increase while the SAE values decrease at the same time. So the AAE values didn't change that much. So the AAE values were between 1 and 1.5. Sorry. The second case that I wanted to show you is happening June 1st. During this dust event that was a haboob, we had 2 consecutive bursts of dust. Here we have PM10 values that were 230 and 120 micrograms per cubic meter. The AAE range between 1 and 1.3, were a little bit lower than the synoptic event. The SAE values were close to 0, meaning big particles. And if we look at the high split back trajectory, we can see that it came from the east. This is very typical for convective events here in El Paso. Looking at the graph, we can see that in the afternoon, we have the first burst of dust that lasted for 35 minutes. We have the same pattern that the SAE values decrease while the PM10 values increases. Later, like 2 hours later, we have another burst of dust, like lasted for 25 minutes. And similarly to the other one, we have that the PM10 values increase while the SAE values decreases. This is like interesting because we can see that it's important to have high resolution in the measurements because these bursts of dust could be lost in like 1 hour average or 24-hour average. And here we can see it pretty clearly. So the last case that I wanted to show you happened on June 21st. So this happened very early in the morning, and this was a very complex event. Here we have some synoptic processes. During this day, we have the highest 24-hour PM10 concentrations of the period that we measure. It was 110 micrograms per cubic meter, and the peak was 670 micrograms per cubic meter. So after the dust event, we have that it was followed by an increase on the AAE and the SAE values, meaning that we could have brown carbon coming from the northwest, where we have some forest fires there in New Mexico and Arizona. And after the increase in the AAE and the SAE, we have that a cold front hits from the northeast in the afternoon, and the aerosol properties change very rapidly. So here we have the forest fires from the northwest and the cold front from the northeast. Now, this was the dust event around 1 a.m. right here. The peak of the highest concentration of PM10 particles was like 670. It lasted for a few hours. After that, we have a decrease in the PM10 levels, and then we have an increase in the SAE values right here. And at the same time, we have an increase in the absorption Armstrong exponent. That meaning that we could have like brown carbon there. And then after that, when the cold front passes, we have a rapid change in the SAE and the AAE values. So they return to normal. So I think that's pretty interesting because we have like this very complex event, and we could see the evolution of this event with this high resolution data. So here I just wanted to show you some like summary of the data. So the background levels of PM10 and PM2.5 were 28 and 8. So during the dust, we have like these levels were 6 times higher, and similarly happened to the PM2.5, were like 5 times higher. So as a conclusion, we can say that during this period of measurements, we have 25 dust events. We could capture those 25 dust events from April to June of 2021 in El Paso BC Square site. 14 of these events were produced by synoptic and 11 by convecting processes. The PM10 concentrations were about 6 times higher during the dust than non-dust conditions or background. And the PM10 concentrations were about 5 times higher. During convective dust events, we have higher PM10 concentrations than synoptic events. And June was the dustiest month with 48% of the events. And also during June, we have several dust events with PM10 concentrations higher than 1,000 micrograms per cubic meter, which is 33 times higher than the background. One interesting thing here is that the AAE values during the dust events were relatively low compared with the literature, because we found that during our dust events, we have values of AAE close to 1.2, while published data or published AAE values for mineral dust are higher than 2, or if it's polluted, is higher than 1.5. So the AAE values for dust in this study are possibly due to the chemical composition of the dust in the Chihuahuan Desert which is relatively low in iron and high in calcium carbonates, and or a mix with urban aerosols that make the absorption decrease. And the high time resolution of this data illustrates the evolution of complex dust events that could be lost in 24 hours. And that will be all. So if you have any questions.
Yes, we have one question from Zinti. Is asking, how do you distinguish between synoptic and convective events?
Pretty much to distinguish this, it was based in observations and use satellite imaging to. I couldn't show you because I thought it was like a lot of data, or I was going run out of time. But yeah, it was based on observation and satellite imaging.
Great, thank you. Do you have any more questions or comments for Gedman? So another question is that manual or automated?
The what the distinguish between the synoptic and convective events, or the processing of the data, because the processing was like automated, but the distinguish between those kind of event was manual, pretty much.
Yeah, we don't seem to get any kind of follow-up. So go ahead and see your question answered. And so, yeah, we're going on to the rolling through. Thank you very much for your presentation, Gedman. That was very interesting as far as seeing that direct relationship with the dust event, and seeing that SAE being directly reflected.
Yeah, thank you so much.
And so then we'll go ahead and go on to our next presentation with Ramesh Singh from Chapman University. And so we'll be discussing growing dust storms, impacts on air quality, meteorological and atmospheric parameters.
Morning. Are you able to hear me? Hello.
Yes,
I
hear you very faintly.
Are you able to hear me?
That sounds a little bit better.
Okay. Let me see. Okay. Do you see my screen?
Yes. Yes. Thank you.
Okay. So thank you very much. Why there's an echo coming up? I see some echo. Oh God. This is the problem. I'm not sure why I'm getting echo. Okay, I'm going to talk about the. Is it possible to fix this problem?
Do you want to send me your slides, and then I can go ahead and pull it up, and I can.
No. This is not the problem with the slide. This is a problem with the echo. This is a problem with the echo, Amanda.
We're seeing the slides okay on our end, Ramesh.
Okay, then fine. So I'm going to discuss about the growing dust storms. Okay, I do not know whether it is growing. Okay, we have to discuss this one. And I want to discuss about the impact of the air quality, meteorological, and atmospheric parameters. Some of problems was highlighted by German, okay, and he talked about the dust storms, 2 dust storms, okay. So let's try to see what are the sources for the dust storms, okay. So this is the important point, okay. So the sources are, you can see different sources, the global, okay, and then you can see what are the characteristics of the desert dust. The average annual rainfall of less than 25 centimeter per year, and the desert covers about 25% of the Earth's surface. Deserts are defined by aridity, okay, and you can see, you can identify the deserts, global deserts. The global deserts, you can see the image satellite map, and the albedo is very high, so it shows a very prominent image, the location of the dust you can see in the world. So the dust source region suffer with the aridity, drought conditions, soil cover with low moisture, the traffic dust, local dust sources, constructions, and long range transport of dust. We are talking about the long range transport of dust. And German, he talked about some of the events, okay, and what are the dust characteristics is the surface temperature, air temperature, atmospheric pressure, relative humidity, wind speed, and wind directions, and the soil moisture. These are the important parameters. So impact of the dust storms is the atmospheric pollution, health impacts, poor air quality, weather condition change, impacts on the climate. Do we believe in the climate change? So it affects the civil aviation. It impacts the visibility, the fog and smoke, and the total ozone column changes, and the rainfall, it affects the rainfall. So the atmospheric pollution, when we are talking about, it impacts the climate. Okay, you can see when there is the atmospheric pollution, we are more bothered about the health, poor air quality, weather conditions, impacts on the climate, civil aviation, visibility, fog and smoke, biodiversity, ecological imbalance uh, in a total ozone column, urban heat island, poor monsoon, and acid rain. So these are the impacts. Okay, and you can see here one time we commented on EOS AGU about the climate change. So the earlier administration of US did not believe about the climate change. And one time I was coming from Brazil, they stopped at the Atlanta airport, you see, and the guy started asking me if I believe in the climate change, you see. And I said, yes, please come to my office and I will show you the long-term changes in the parameters, okay? Because the Trump administration did not believe about the climate change. At that time, he was going to be president. Okay, so these people were just making fun of this. So we are very much bothered about the impact of the dust, okay, on the health. And this is why we are very much concerned. And I call dust as a slow poison. And when you suffer with the lungs problem, liver problem, you are admitted in the hospital. If you are lucky, you may come back. Otherwise, you go. Okay, we are talking about the dust over United States. The dust is coming here from the western side through the westerly wind. Dust is coming from easterly wind from Sahara deserts. You can see the uh, June dust over the United States, okay, coming from the easterly wind from Sahara. Okay, as a result, the aerosol's optical depth changes, and you can analyze the satellite data, and all kinds of satellite data provides information about the pronounced changes in the aerosol's optical depth. Okay, so the sources of the dust, California, and because of the drought conditions, over the United States. Okay, and you can see here. I try to analyze the AOD and angstrom exponent from 2003 until 2023 at different parts of the globe. And you can see, if you see aerosols angstrom exponent, that gives you about the dust. So if you consider the AOD and a angstrom exponent, you can characterize about the dust storms, and the German also told us. And this is about the United States. You can see the aerosol's optical depth, and here you can see the peak, and these peaks characterize the sources for the dust storm. One can consider the AOD and angstrom exponent to consider this. And this was a monthly variations. And here in the right panel, I'm showing the daily panel, daily data. And what I see that when the AOD is more than 0.3, those days we can observe the dust storms over the United States. Okay, and the same thing, I downloaded data, and it shows about the dust storms on 31st March 2023 and 4th September 2017. And here about the Sahara, the dust is coming, and you can see the AOD and angstrom exponent, and that characterized about the dust events. Okay, and the same thing I showed at the bottom the daily AOD, and you can see very high AOD, and then you go back and look at the images, you will find the dust storms. This is what I'm trying to show you. Okay, so here you can see about the dust storms in Arabia, and you can see AOD is increasing, and you can see some of the lower peak about the angstrom exponent. If the angstrom exponent shows a lower value, it means those are the dust storms. Okay. Here, there was a one dust storm in Bakersfield, and this paper I published, and I found the changes in the carbon monoxide and a PM 2.5, and also the ozone concentration change. Okay, NO2 changes, and there is a lot of problems in the dust storms, because at the same time dust is there, and sometimes the forest fire, there is a mixing, strong mixing of the dust and smoke. So that is reflected by single scattering albedo values. And then you can see these are the aeronet data, and one can see the volume of the dust, and also the radius of the particle. When the dust is there, the radius, you can see the coarser particles, and these are the reflected from the internet data. Okay, and then one can see what are the characteristics of the source region, and this characteristic I saw from the GRACE data, and one can see what is happening at the source region. Sorry, my slide is moving very fast. Okay. So you can see a declining trend. So it means aridity is changing, the soil moisture is changing, because the water storage is declining. Okay, and so these are the dust storms. When the dust storm is there, the coarser particle is very high. The finer particles, whenever there is a forest fire, you can see the finer particles. Okay, so then you can identify when is the dust storms. Okay, and so these are the dust images mixing with the forest fire. Smoke is coming, and then here is the back trajectory, and whatever Jarman told us, that the dust storm is coming from the southwest and from the westerly wind over the United States. Over India, the one of the local dust storm is the Thar Desert, and plus you can see other dust sources is the Run of Kutch in Gujarat, and then long range transport of dust is coming. And these are the dust storms in Thar. And now recently, what the government did, there is a canal system. So now with the canal system, irrigation team, we are doing, and as a result, the dust is getting suppressed. Okay, and you can see the sources of dust over India. These are the sources coming from Arabia Peninsula. Okay, and sometimes the dust is crossing over the Arabian Sea. As a result, the chlorophyll enhancement one can find. Okay, this is what I'm trying to show you. Okay, that's sometimes the dust reaches over the Himalaya, and it impacts the snow glaciers of the Himalayan region. Okay, and there is a dust season over in India. The dust season is starts from March, April, May, June. Okay, and then it affects Delhi, whole of Indo-Gangetic Plain, where 900 million people they live, and I consider as slow poison. People they don't use a mask, This is the biggest problem there. And the dust reaches over the foothills, over the Himalayan region. As a result, all the relative humidity, the air temperature, the water vapor also changes. And here the dust mixes with the crop residue burning in the western part of India. As a result, the whole atmospheric chemistry changes. And here is the dust storms over Sahara region. Okay, this impacts the dust air quality over the United States. Okay, and here is the dust events over Australia, and when the dust affect the Australian region, the air quality changes, and also it affects the chlorophyll concentration nearby the ocean. This is dust storms in the Beijing, China. And you can see there was a dust storms in April 2001, and from China, it affected the western part of the United States. As a result, you can see the chlorophyll blooming over the ocean. Okay, so I believe the dust storms events are growing. Why it is growing? Because of the climate change, aridity is increasing. Okay, and also the soil moisture is declining, the water storage is declining. So thank you very much.
Thank you, Ramesh.
Thank you.
Does anybody have any questions or comments for Ramesh? Okay, so I'm not getting any questions or comments for Ramesh. So I'll go ahead and roll on to the next presenter. And so this will be Karin Arden Dreyer from Texas Tech University. And she'll be discussing the true impact of dust events on air quality, underestimating the true impact. And so unfortunately, she is not here today. So she has sent me a recording, and I will go ahead and play that for her.
Thank you, Armando, for giving me the opportunity to talk today to you. And I'm very happy to be here and to tell you about the true impact of dust event on air quality. And the focus of this talk will be about dust that's happening here in the US and different places in the US. And we're going to sort of deep into understanding, are we really quantifying their true impact on air quality? And what are things that we should consider or maybe think and do? So before we go deep into looking at different dust events, I want to highlight something very crucial, which is what are aerosol particles that we normally use and the definition that we normally would use when we talk about aerosol particles. So aerosol particle is fine liquid droplets or solid aerosol suspended in the air. Now, normally when we talk about aerosol, we talk about PM 2.5 and PM 10. Now, just to give you the graphs of how small these particles are, there's a single human hair here, and this is the diameter if we face it on the side. So this is an average human hair diameter. And you can see how small the PM 2.5 and PM 10. So PM 2.5 are particulate matter up to 2.5 micron. And a micro is almost 4 to the 10 minus 5 inches, just to give you the graphs of how small these particles are. And PM10 are particulate matter up to 10 micron. Now, when we're talking about dust event, we have a lot of these particulate matter into the air, both PM2.5 and PM10. And you can see those different examples of some of different dust storms and dust events that are happening with these high concentration of particles. Now, when we talk about dust event in general, we know that there's different aspects. There's economical aspect, there's agricultural aspect, there's impact on coral reef, there's impact on cloud microphysics and precipitation process, impact on radiation, obviously impact on our life and our well-being, a lot of car accident that happening. But when we talk about one of the crucial aspects, which is our health, we need to understand that how many of these particles, based on their size, we can actually breathe in. So when we talk about aerosol particles, and we talk about the impact of health, it's really defined by the sizes of the particle. Larger particle penetrate into the upper part of our throat. The smaller they are, they can go into the upper respiratory or even smaller into the lungs. Now, we do have some mechanism to protect us from getting a lot of these particles in. For example, our eyelashes, the hair in the nose, the mucus that usually you get when there's a lot of dust particle into the air, the coughing to help create that, get them out. And there's also mechanism inside our body, specific cell that's supposed to target and remove those dust particles from the atmosphere. Unfortunately, studies shown that some of these mechanisms are overwhelmed and cannot really protect us when we're breathing, when we're outside and there's a lot of particle in. And truthfully, the minute you breathe those particles in, they're sort of stuck there. It's very hard for them to get out of your lungs. So it's something that we need to think about. Now, how do we examine the impact of dust on air quality? There are different definitions, which are basically threshold that has been created either by the World Health Organization or by EPA, which is our US base, to define what would be a criteria. Above it, it would not be healthy to breathe it. Majority of these studies that created these criteria, which are epidemiological studies, are based on anthropogenic pollution, based on not dust. So looking into the impact on air quality of these dust events, normally we would see what is the daily values of either PM2.5 or PM10 on a specific day, and is the value above these thresholds. Now, the World Health Organization defined a threshold for PM2.5 as 25 micrograms per cubic meter and PM10 as 50. These are smaller, lower than the EPA threshold, which are 35 for PM2.5 and 150 for PM10. And recently, in 2021, the World Health Organization updated the threshold based on different studies showing that we want to reduce the impact, because we found that even these concentrations slightly above them, it's going to be very problematic and killing many people. As we see, millions of people are dying every year because of pollution. So what does it mean about dust storm and dust event in the US? I'll start with an example from a far place. This is an example from Israel. Israel, as you know, located in the Mediterranean, experienced many dust storms and dust events. And this is just one example that I measured during my PhD there. And we can see here the concentration as a function of time. In red, we see the PM2.5. In blue, we see the PM10. And these are just the changes over time. But when we average the concentration on a daily basis, we see that the PM2.5 was 149, the PM10 was 812, way above the threshold of EPA or the World Health Organization. So yes, definitely, you do not want to be outside when you have such a big dust storm. And obviously, you can just see it by the photo when you can't really see for a distance. And this is something that we've also seen in the US. Here's an example from Lubbock. This is a big dust storm that occurred here in December 15, 2003. Stay tuned to hear about a more severe dust storm that occurred very recently. I believe it's the next stop. So going back to this example, we can see during the day the concentration of PM2.5 increased to 500, and the daily average in this case for PM2.5 was 70 microgram per cubic meter, which again is above the health organization or the EPA. Similar example from another place, Phoenix. This is a big dust storm that occurred in July 2011. You can see here the PM10 concentration, hourly concentration, and PM2.5 concentration. Concentration went to more than 1,000 for PM2.5 hourly values, and more than 5,000 for the hourly values for PM10. And these are based on different sensors that spread across the Great Phoenix area. And again, when we look at the daily values, depending on the sensor, we see that they're ranged. Some of them were right above the threshold of the EPA, and some of them were really high compared to the definition that the EPA or the World Health Organization. And this is something we've been seeing in many places. The following example is analysis that we've performed for 3 of the West Texas cities that we have here in West Texas, which is Amarillo, Lubbock, and Odessa. Now, in black, you see the hourly max concentration, and in the different color, you see the daily values. And this threshold, this line here, is the EPA threshold. Now, we notice that majority of the colored value do not pass the threshold, but there's way more hourly values, very strong event. So we decided to examine what type of event are they? How many of them are dust event? And how many of them are really passing those daily criteria? Now, we've already performed this work for Lubbock for a dust event. And this is in Kelly and Arden Dreyer from 2022, I believe. And we decided basically to expand it because what we found was something similar for Lubbock that I'm going to show you now for Amarillo. We found that some dust events last for hours, and their concentration may not exceed, and this is the concentration here in red, the concentration in red may not exceed other event, but they'll last for very few hours. And the daily average during these events would be this, and this is PM2.5, which would be above all the threshold. On the other hand, by the way, we have here wind speed and wind gust also, so you can see the increase. So these are long-term events, and there's also a lot of short-term event, convective events. And this is an example from Amarillo. We see that the concentration of particle really increased to high concentration. But when we calculate the daily value for this event, because this event is so short, it averaged all the hourly concentration that were measured, and we see a very low value, below even the most updated WHO. Now, 75% of the days in Amarillo that had daily values, hourly values above 100 micron, actually had daily values below the EPA, which mean if we would just look at the daily values without looking at the actual distribution of the hours of how the PM changed, we would miss that. The best example I like to use defining this is this specific dust storm that happened here in Lubbock, Texas in 2011, because you can see that you cannot see the concentration or the air. So here it is, one of the biggest dust storm or haboob that we had here in 2011. Now, again, if we look at the PM2.5 concentration for that day, we see that it increased to more than 150 microgram, but it's very relatively short. And because it's short event, when we average it, it's 23.5 microgram per cubic meter daily values. So although it might be below the old WHO and the EPA, with the current updated WHO, it's definitely a day that would be flagged. But overall, we can see that average across the day mask the fluctuation of dust in the air which basically make us to miss some of dust events that occur in the US and miss the ability to capture these events and take them into account, especially when we're doing a lot of studies related to health. Here's another example that happened recently in July of 2021 in Phoenix, Arizona. You can look at the video and just see the amount of dust in the air. Now, again, these are based on different stations from Phoenix. These are the hourly values, and you can see here the daily values. But I want to pinpoint another very interesting example. When it comes to a lot of convective events, as I mentioned earlier, they're very short in duration. They last for 10, 20, 30, 40 minutes. So when you even average those PM10 concentration, as we have here in the example, you basically skewed and reduced the true concentration of these particles in the air. So here are some examples. When we look at the concentration of this specific station, which is located here in Phoenix, and these are just 10-minute values, average of 10 minutes, we can see a very high peak of concentration, more than 8,000 particles per cubic meter for PM10. But again, when we average the hour just for that specific time, it shrink it down to slightly less than 3,000, which still would be high. But again, we're sort of reducing the true impact. See it again with a similar concept for PM2.5. And you can see here these different examples. Here's the concentration of PM2.5 with, again, the same sensor, more than 800 microgram per cubic meter. If you were outside during this time at that peak, you would be exposed to very high concentration of particles. But because we're averaging per hour, then it's basically reducing the true impact of this event. And again, you can see here that majority of these days were below the threshold, which means we would just miss them if we would just look at them based on the daily values. All right, here's some more examples just to get us to understand that we're missing some of them, and there's a lot of information that we need. So this is a very interesting dust event that occurred here in Texas, again in 2021. We have here a combination of synoptic and convective dust event. Unfortunately, they were combined together here, but there's no sensor, so we couldn't really detect them and see the true impact. But I will show you the case of of Odessa and also Houston. So here's the concentration that were measured in the PM2.5 in Odessa, which located around here. So it got most of the synoptic dust event. And this is the one from Houston. The dust that moved from West Texas, made it all the way to Houston, and those particles were captured the morning after in Houston. Just to show you that this event, capturing this convective event from the ground, this is how it looks like. So these are images that were taken by Alex, who is one of our graduate students in the atmospheric program here at Texas Tech University. So a lot of particle in the air, but as I mentioned, unfortunately, there are no sensor in this area allowing us to capture these convective and synoptic events together. Now, if we're looking across this area of this event, obviously you saw the photo, there were a lot of particle in the air. We see that the increase in particle was observed in each one of the stations from West Texas all the way to Houston. There were increase in particle concentration all the way. But again, when we calculate the daily values, all of them are way below the threshold, which means if we're only looking at the daily concept, we would miss these days. We would not even consider them. A lot of the time when we get information on daily values, we only get the average, which show this example. So we have here 3 events that were captured here in Lubbock, Texas, with the station that we have called Eros. And these are the daily average. So just looking at the daily average, you would not think that this had anything specific, interesting, looked very fine, it's below the threshold. This maybe there's something here, but I want to show you the threshold, the standard deviations, which obviously, if you look at the standard deviation for that day, you understand something happened. There was some event, and each one of them had a different dust event, a synoptic dust event and 2 convective dust event. And the other interesting aspect, which I showed for Arizona, I want to highlight here. If we're just looking at hourly values for these dust events, we would suspect, and we have here the different PM concentration and the different sizes, and as a function of time, these are hourly values. So if we're just looking at hourly value, we would imagine, oh, this synoptic dust event had a lot of particle, it's probably very problematic. But these convective didn't have that much particle, so probably we shouldn't worry about convective event. But remember, these were very short duration event. And when we change the way that we look at the data, in this case, we're averaging the concentration every 10 minutes, we can finally see the true impact of these dust events, these convective events, on the concentration of particle, way higher concentration than what we had for the synoptic. Now, obviously, we don't have enough measurement across the US, and we normally do not have measurement at low or short-term intervals. Most of their measurement provided by the EPA or any air quality organization are normally provided as an hourly basis. So what do we need to do? First of all, we see the daily average, which are used to calculate the air quality values, may not reflect the true impact of dust event, mainly those who are short duration. And those short time measurement, like the 10 minutes that I showed you, can capture the true impact of dust particles and their contribution into the air. Because if you're outside, you can breathe those particles in. Now, we definitely need to rethink the way we evaluate the impact of dust event on air quality and therefore on human health. Perhaps we should start think about acute exposure, which are very short-term exposure, and try to define them better and not neglect hourly values and not neglect short-term measurement. So with that, I would like to emphasize that if you're interested in dust, please join DANA, which is Dust Alliance for North America. We have our webinar every month, and we're always happy to bring people who are interested in dust into the community and get to know more people and collaborate and basically increase awareness and also emphasize on our mission. So we have our webinar coming up this Friday, so please join us. Again, I want to not just wrap up the quick talk because of the time. I want to acknowledge the team members of my group who were able to provide the hard work for this data, and also the Maricopa County for Air Quality, the Department of Maricopa County for Air Quality, who provided us with the 10-minute raw data for Maricopa for the Great Phoenix area. Thank you so much for your time and for your attention. And if there's time, I'll be happy to take questions. Thank you.
Okay, so since Karine is not available here to take questions today, if you have any questions, feel free to forward them or write them in the chat, and I'll go ahead and forward them to Karine so that she can answer them at a later time. We'll go ahead and roll on to our next presentation. And we'll have Mary Robinson from Texas Tech University. And today she'll be discussing a case study on the West Texas dust storm on February 26, 2023.
Hello, can you hear me?
Yes, I can hear you.
And you
I
can see my presentation?
Yes, thank you.
Okay. Hi, thank you, Armando. Like he said, my name is Mary Robinson. I actually go by Cece though. And today I will be talking to you on a case study that we did on the February 26, 2023 dust storm. I know Joe talked about it a little bit, but I will be going in more depth about what actually happened in New Mexico as well as West Texas. So first, just a brief little outline. I'm going to touch on just a little bit of dust storms first, and then just a little bit on the February 26th dust storm, the meteorological overview of why it occurred, what happened that day, the methodology that we used, and then I will be discussing ASOS data as well as PM data. So first, Dust storms, southwestern United States, as I'm sure y'all know, are prone to dust storms just due to the arid and semi-arid environments, as well as the surrounding deserts and agriculture, especially in New Mexico and West Texas. For example, Lubbock, Texas experiences about 20 blowing dust events a year. I found that out in my paper, Kelly and et al. 2021. And the World Meteorological Organization has two different definitions for dust. So first, a blowing dust event is when visibilities are from 1 to 10 kilometers, and it is considered a dust storm if visibilities are less than 1 kilometer. So then on February 26th, we had a big dust storm event that first initiated in New Mexico, and it traveled eastward into West Texas, and I believe it actually went farther into eastern Texas. I don't know exactly where, but because I focus more on New Mexico and West Texas, but I know it actually did go into eastern Texas. And this is a picture that I got from Jeff at the National Weather Service office in Albuquerque, and this is just from their camera at their office showing during the dust event when it first started occurring at Albuquerque. So this is a video that I took before I press play. I just want to say, please don't try this at home. I just happened to be driving right as it hit in Lubbock, and this is just me driving down the street. This was actually when the worst of the storm hit, and you can see that car maybe was 15 to 20 feet in front of me, and you can barely see it. There was a car behind me, and I couldn't even see their headlights. It was just really, really bad, and I think we were maybe going like 5 miles an hour or something. I've never been in or actually driven in such a worse storm before, and I was actually really, really scared at the time. But I figured I should record it because it was such a significant event. So first, a meteorological overview. So in the early morning hours on February 26th, there was a low pressure system that was sitting over California that moved eastward into the Four Corners region. And with that low pressure system, there was a 500 millibar jet streak at 100 to 120 knots. And there was also a 700 millibar jet streak that was about 60 to 70 knots around that time. There was also intense surface cyclogenesis that was on the leeward side of Rockies, and that was moving eastward throughout the day. And then from that, there was significant daytime heating and mixing, which resulted those strong winds from both of those jet streaks to reach the surface. There was also a weak dry line that you can see in this picture right here. The colors are dew points, so you can see moist air and dry air. We had a dry line that moved through West Texas. And then behind the dry line, we actually had a Pacific cold front, like Joe mentioned prior. And that also moved through West Texas. And it actually ended up colliding with the dry line. And it resulted in some significant thunderstorms, I believe, to the north of Lubbock, as well as to the east. And this is just a picture of the max wind gust that was recorded on February 26th from all of the West Texas mesonets. Here in Lubbock, the greatest was 35 meters per second. You see up here, we have one that was 51 meters per second, and that one was actually from an outflow of a thunderstorm that was initiated from the colliding of the dry line and the cold front. But most of the winds that we got from this event were a result of the cold front moving through the area. So for methodology, what we wanted to do is we just wanted to see how it affected these areas, how it affected New Mexico, West Texas, how it was different from where it first initiated to when it moved through West Texas. So to do that, I used automatic surface observation stations, or ASOS stations, and these are generally located at airports. And this is just a map over here on the right that shows all the ASOS stations that I used throughout New Mexico and Texas. And the way we looked at when the dust storm first initiated and ended in an area, we looked at what was called the present weather code in these METARs. And this is where either the ASOS station manually puts in a code, or if there is a weather observer or air traffic control employee at the time, can manually go in and enter in weather codes of whatever is occurring at the time. So for this, we used BLDU, which stands for blowing dust, DU, widespread dust, DS is dust storm, and haze is HC. And I would like to point out that BLDU, DU, and DS are not able to be automatically put in by the ASOS station because they can't determine what is actually lowering the visibility. So if there is not a person there to manually enter in that dust code, then it will automatically put in haze. So we also included haze on top of the other dust codes. So for particulate matter, we use multiple stations around New Mexico and Texas. For Texas, we use the Texas Commission on Environmental Quality. They have multiple PM stations around Texas. And I used Amarillo, Lubbock, Midland, Odessa, and there was 3 in El Paso. And then for New Mexico Environment Department has many stations around New Mexico that we used. And then for Albuquerque, they actually have their own station that they take care of themselves. And they actually gave me the PM data for their region. And this is just a map that shows all the stations that we used and where they're located. So first, let's look at the New Mexico ASOS. So it was first recorded in Albuquerque at 10:15 in the morning, and the final dust observation was at Holloman Air Force Base at 18:44 in the evening. So just for time purposes, we're only going to look at the stations that experience dust storm conditions. Just a reminder, that means visibilities were less than 1 kilometer. So we have Clovis, Roswell, Tucumcari, Alamogordo White, and Holloman Air Force Base. And you can see 0.4 kilometers at Clovis, 0.8 for Roswell, Tucumcari, and Holloman Air Force Base, and then 0.4 at Alamogordo White. And I also have how long the observation or the visibility observations were less than 1 kilometer. And you can see the bottom 3 are 5 to 6 minutes. And in retrospect, that really isn't that long. But if you are outside during those 5 minutes, or let's say you're driving during those 5 minutes, you can potentially, inhale those particles, causing some health problems. Or if you're driving, it just takes a few seconds for a really bad wreck to happen, especially if people aren't paying attention. So in hindsight, it's a short time, but also I believe with such low visibilities, it's very significant. So then moving into Texas, for Texas, it was first recorded by El Paso at 12:05, and the final observation was in Lubbock at 3:55 the following day on the 27th. And again, I'm only showing stations that experienced dust storm conditions. So first we have Lubbock, and Lubbock, the visibility, I believe it was about 15 to 20 minutes, that visibility was 0. And if you remember my video, around the time that I was driving was when visibilities got to close to 0. But for 80 minutes, our visibility was less than 1 kilometer. And then we have Hereford and Lamesa. Hereford for about 40 minutes, their visibility was less than 1 kilometer. And in Lamesa, also 40 minutes, where their visibility was less than 1 kilometer. So it's significantly longer than the 5 to 6 minutes. So there was a chance of, health problems, wrecks, all of that kind of stuff that usually occurs with lower visibilities from dust storms. So next, I looked at particulate matter, and for time's sake, we are only going to be looking at the PM stations that exceeded the EPA daily PM 2.5 and 10 standards. So first, this top row are the 3 stations that exceeded the PM 2.5 daily standard of 35 micrograms per meter cubed. And it's actually Lubbock, Amarillo, and El Paso. There weren't any PM 2.5 stations in New Mexico that exceeded the daily average. But Lubbock, the daily average was 69, Amarillo 36, and one station, El Paso, was 53.6. Then next we looked at PM10, and that's going to be all 6 of these little figures right here. One from Texas, so one El Paso station exceeded the daily average, while the other 5 are from New Mexico. And I just want to point out like 205, 278, and even up into the 700s for the daily average. So these were pretty high and significantly higher than the EPA daily standard. I also wanted to mention that 9 stations, or 9 PM 2.5 stations exceeded the WHO standard of 15 micrograms per meter cubed, and 11 stations exceeded the daily PM10 standard for WHO. And so this, I just wanted to show, it's a GOES East Dust RGB. So for those who haven't looked at this before, the bright pink color that you see in each picture, that's actually the dust. So this is about the start, the start of the dust event over New Mexico, and it like travels through time. And I just wanted to show this because you can see how the brighter it is, the more dust there is. So it's very bright pink all throughout the time. And then this last one, I really like because you can see the dry line as well as the cold front, because this was around the time that it about collided. But it also shows how bad of an air quality event this was. So this was for Lubbock specifically, this was the worst air quality event in the past 20 years. The highest PM 2.5 hourly average recorded in Lubbock was 518.4, and previously it was an event in December of 2012 at 485.5. So specifically for Lubbock, especially like duration and PM measurements, this is the worst one that actually occurred for Lubbock. All right, I just want to acknowledge Armando, which y'all already know, and Patrick Hudson from Albuquerque for the particulate matter data from New Mexico. And with that, I will take any questions.
Thank you very much, Mary. That was very interesting. And so it's interesting to see that that you have the worst air quality day just this past February.
Yeah.
Interesting. And so does anybody have any questions or comments for Mary? Yeah, Joe, just wanted to let you know it was a great presentation and synopsis. Okay, so well, if we don't have any other questions or comments for Mary, I think this is an appropriate place to take a break so that we can go ahead and catch up with our agenda. So we'll go ahead and come back at about let's see, about 12 minutes so that we can get back on schedule with our agenda, because the thing is we're having this town hall meeting starting at the end of our presentations. So we want to kind of get back on track here. So we'll be back in about 12 minutes. Thank you. Well, it was a nice break with the full agenda that we have this morning. So I'm gonna just call people back for us to continue our agenda. And so I'm gonna go ahead and play another presentation by Karin Arendreyer from Texas Tech University, where she'll be discussing when a dust storm is not a dust storm, the reliability of dust records from the storm events database. And so that'll be our next presentation here. Thank you.
Hello again. Today I'm going to talk about a paper that we published recently, and we're going to talk about when a dust storm is not a dust storm, and basically a reliability of the dust storm database. So I want to acknowledge first the co-author for this presentation and for the paper, which are Professor Tom Gill and Professor Daniel Tong. And the paper was published earlier in GeoHealth, so feel free to go look at it, read it, and send me questions or comments. So before we start, I want to highlight something that is very crucial. In our community and in the public, we've been seeing people that confuse between the term dust storm and dust event. And even I made the mistake in the past calling every dust event a dust storm. So what is a dust storm? What is a dust event? According to the World Meteorological Organization, a dust storm would be defined when the visibility will be reduced below 1 kilometer. And a dust event would be an event where the visibility will be between 1 to 10 kilometers. Now, here in the US, the National Weather Service even have more strict criteria to define dust storm, and they identify it when the visibility is reduced to 0.4 kilometer, which is a quarter of a mile. So doing this different definition, I came across the dust storm database, and it has been something that's been used in many papers and many studies. Some of them, and majority of them, are related to the impact of dust storm in health, which is one of the biggest questions that we still have here in the US, and there's really more study that I'm hoping will come out in the next few years about the topic. So these different studies use this database to look into the health of elderly people or even infant and pregnancy on the impact of dust storm in the US based on the dust storm database. So I was very curious to know about this storm database, and we decided to explore it more. So the NOAA Storm Event Database is a database that accumulates different type of severe conditions. One of them is dust storm. And it's a database that exists for several years. We decided to look at the event from 2000 till the end of 2020 across the US, across the nation. And when you look at the data, you can get data per year or per county. And usually it comes out as an Excel that give you the first time date and hour of report, and the end of the report. There's also information about injuries and damage, and who made the report. Was it general public? Was it a law officer, a law enforcement, sorry? Was it a broadcast media? Was it in the weather meteorological station like ESOS or other station, or maybe the report was made by an official National Weather Service personnel. And each one of them can put into the report what was the WFO, the office that actually made this report, which helped us to identify the location. So we took the database across the US from 2000 to 2020, and we found, after combining events that happened in the same state, we found 647 dust storms reported in the storm database from 2000 to 2020. We can see here a different temporal distribution and also duration of these events across the US. And the first plot, we see an increase in the number of dust storms that was reported from 2000 to 2020. And we can see the variation. Some years had more than 50 reports. We also see that there's some months that has more reports than others, and in this case it's July and August. We're going to get to that later on to understand if it's maybe skewed by specific location. We see that majority of the dust storm reported in the storm database are in the late afternoon to early evening, and majority of them are less than 1 hour. So less than 1 hour report in the storm database. When we took that data and break it into a state, we notice that there's some states that had way more reports than others. For example, Arizona had 288 reports, and California had 184. And we can see the distribution of other states across the nation. And we can definitely see some states that don't have reports in the storm database, but there has been some dust storm in them. So this starts raising the question about how the data is accurate, but I want to go on and show you additional data that we found. So when we took each one of the states and separated based on month of occurrence, we definitely see that Arizona is most likely the one that skewed the total distribution, as most of the dust storm event in Arizona are happening over the summer, over July and August. And that's probably what, because of the high number of events there, that's probably what skewed most of the result. But the interesting thing that we can see here from this plot, and these are just the state that had more than 20 events, that there's different distributions. Some events have more event in early spring, some state has more event in late spring or even in the fall, and others like Arizona have most of the event in early summer. So we really wanted to understand, how is this database reliable? Can we really use it for all these studies? So we decided to examine it. The first thing that we did was basically try to understand, is this increasing trend of dust storm? We see that there's more reports as time progresses. Is it real, or maybe it is something because of awareness? And we found that the number of reports increase over time. So there's more line reported in the storm database. So maybe there's more awareness, and that's why there's more report. Is it really because we have more dust storm? That is something we're still not sure about. We also noticed that majority of the reports were made by trained spotter or law enforcement. But if you look at the total per state, that varies. There's some states that had more report by the media, and Arizona had reports by law enforcement. So this variance of report was very questionable. How reliable are some of these reports? Are they based on observation of someone who is trained, or someone that just see dust into the air and define it as a dust storm? We also examine the number of injuries that this event, every dust storm event had, and also number of deaths. Unfortunately, we know people can lose their life during dust event or dust storm, like the one we had last week in Illinois, and this is devastating, and it's something that we've seen. But we've also noticed, as we looked at each of these reports, that there were some reports that were missing. Some dust storm here that did not have information in the table that was provided. There was some information in the description, which is something that's sometimes added into each line of report. And they had information on injuries or on damage, but that was not interpreted and added into the table. So this has really started some questioning about, how is the data, how can we trust the data? What does it represent? Now, in terms of injuries and death, we definitely see that there's a skew. When we have more numbers of reports per state, we obviously see more death and more injuries. And obviously they're proportional to one another. And again, majority of them were reported for Arizona because there were so many reports in it. So we ended up deciding to look at each one of the dust storm reported in the storm database and trying to see, can we actually identify what were the meteorological condition in each one of them. Now, as I said, in many of the cases, we have the WFO, which are the area that had the reports of the dust storm in the database, and we can look back and identify all the meteorological station, all the ESOS, the automatic meteorological station in the region. And we basically went into each one of those 647 events and looked at each one of them to identify were there actually conditioned to define dust event. So out of the 647 dust events, 156 of them could not be examined because there were no ESOS nearby that we could actually look at the data. So we ended up with 491 dust storm event reported in the storm event database. So when we look at those 491 dust storm reports, we found that 187 of them, which is 38% of the data, were actually dust storm, and the visibility in them was less than 1 kilometer. But almost 60% of these were actually even based on the local, our National Weather Service, with the visibility that was below the 0.4 kilometer. So 107 dust storm were found, confirmed, but what about the remaining? 304 dust storm reports could not had any reduction in visibility. We looked at the data, we can see the wind increase, but there was really no reduction on visibility. And 245 of these 491 events, which are almost 50%, were not supposed to be dust storm. When we examined all the ESO stations in the area that had the report, the visibility was above 1 kilometer. And this should have been defined as a BLDU event and not as a dust storm event. So to highlight some of these examples and some of the problem, we took 4 different states just to showcase the different example based on the storm database and some of analysis that we confirmed for each of the ESO station. So today I'm going to highlight just 2 examples, which would be the one from Texas and the one from Arizona, but feel free to go look into the paper to try to identify or observe the other location. So starting with the example of Lubbock, there were 14 dust storm reports for Lubbock from 2000 to 2020. And we looked at those 14 dust storm events and we examined each one of them looking at the ESO station from Lubbock and the surrounding. And we actually found that 46 of these events, 46% of these 14 dust storm events did not have visibility below 1 kilometer. And you can see here the example of December 17, 2016, which is reported in the storm database. But in red, we have the wind speed, in green, we have the gust, and in black, the visibility. Visibility did not went below 5 kilometer, which basically tell us there were not conditions that should be defined as dust storm for this event that was reported in the storm database. We also found that we have database for Lubbock for dust that occur in the last 20 years here. And we were able to sort of go and track each one of those events reported in the storm database and actually see that in total, there were 26 dust storms in the SO station based on visibility below 1 kilometer during 2020-26. 20 of these events, which is 77% of those 26 dust storms, were not reported in the storm database. They were not even there. And here are two examples. The big dust storm that occurred here in December 15, 2003, where the visibility in black really dropped to less than 1 kilometer, even 0.4 kilometer for some time. And also January 22, 2012. These are two dust storm events, very severe dust storm event, as you can see by the increase of wind speed and wind gust and the reduction of visibility. And two of these dust storms are not in the dust storm database. Also, we were very surprised to see that El Paso, which is one of the locations in Texas that has many dust storms event and dust event in general, were not even mentioned in the storm database. This is really came as to as sort of as a puzzle. Why is it not even has a single report for this duration of time? So this is just one example from Texas. The second example I want to highlight is the one from Arizona. We have database for Arizona, and I'm going to show you some of it now, which is part of a paper that we've been working on and we're hoping to submit really soon, where we examine dust event and dust storm for the Great Phoenix area from 9 ESO stations from 2005 to 2021. Now, in the storm database, there has been 87 dust storm report for the Great Phoenix area, which cover the area that we're actually familiar with. 40 dust storm events in that area had visibility below 1 kilometer. So 40 dust storm out of the 87 were confirmed as dust storm event. 27 dust storm reported in the Great Phoenix area in the storm database did not have visibility above 1 kilometer. Which was very, again, puzzling. Why would it be defined? Why would it be reported in the storm database if it's not really found as an observation? That is something that was puzzled for us. But because we have records of dust event and dust storm that occur in the Great Phoenix area from this period of year, we were able to identify additional 47 dust storm events that were missing in the storm event database. So almost more than half of those who report for the area were not really in the database. So this is really came to us as a surprise, but I want to sort of highlight some of these findings and some of the aspects that we're hoping we as a community will do. So the first thing is that the storm database miss many dust storms event. And many of those who are report in the storm database are not really dust storm. They didn't have visibility that was below 1 kilometer. They should have been defined as BLDU. Also, there's multiple entries in the database from various sources on a single dust storm event. And if you're doing analysis that would be driven by long-term dust trend, you might get confused. And it might skew some of your results. Also, we think that some of the cause of the underrepresentation of dust storm event or the confusion in reporting of dust storm event might be attributed to the various and very diverse sources who contribute to the report, from the public to newsletter to weather amateur to an official National Weather Service observer. Maybe that's sort of what keeping it the lack of consistency in the report, but also there's not a lot of verification in the report, and we understand there's overwhelmed with all the amount of reports, and we're going to need multiple people to just go in and verify that these events were actually reported as dust storm event. Now, although it is one of the most widely used dust storm database and very impactful on weather event available for the US, it's the only database that we have for the US for dust storm. A lot of issues that were found in this study basically raised the question of how accurate is the data, how reliable is the data when it comes to studying the impact of dust on climatology or on sociological and health component. So we basically recommend to people, to those who are using this database for any study, mainly for health, for safety, on other kind of study, just to be cautious and to understand the potential limitation that this data might have, and basically be aware when you're performing your studies, because your finding might be skewed if you're defining these events as dust storm, but some of them will not be. So to wrap up this talk, I want to highlight the fact that this finding, really something that raised up, is the fact that we really don't have in-depth database for dust event and dust storm in the US. And I'm happy to say that I recently received a grant from NSF to do exactly that. So stay tuned. Maybe in the next few years, we will be able to share a database that will contain the entire US from 2000 to 2020. And we're hoping to provide to you a database that will confirm those dust storm and dust event and additional information that we'll be able to share. So stay tuned to that. Thank you so much for your attention, and I'll be happy to take any question if there's time. Thank you.
Thank you, Karim. And so if you have any questions or comments for Karim, feel free to provide them in the chat or the link that I had provided in the chat earlier. And we'll go ahead and forward those and get those answered, even if you have them later on. So I'm gonna go ahead and roll through to the next presentation with Jason Mondragon Martin with the Natural Resources Conservation Service with the U.S. Department of Agriculture. And so today he'll be discussing the rangeland management and the effects on windborne dust.
Hello, everyone. Thanks for having me here today. Let me get things going as far as the this presentation's concerned. All right. So, as mentioned, my name is Jason Mondragon Martin, and I am the Assistant State Conservationist for Field Operations for the North area of New Mexico with the Natural Resources Conservation Service. You might have also heard this position called the North Area Conservationist position. My counterpart is Adrian Tafoya in Las Cruces. So I know I'm a little bit outside of where a lot of the discussions focused on, but I think a lot of the things I'm going to talk about can span both the north area and the south area of New Mexico. Also, while we've talked a lot today about a lot of technical stuff, and I will admit I am not anywhere near as well versed in the scientific aspects of windborne dust as everybody who's come before. I feel a little bit intimidated by that. I'm going to look a little bit more at the policy side of things. So what I wanted to talk today about was rangeland management and how I can tie into dust control for and reducing the amount of particulate matter coming in from windborne events. And a big reason why I want to focus on range management is because the land use in New Mexico is incredibly dominated by rangeland. We have 80% of the area that's it's either shrubby cover or just or grassland. 15% of that is forest land, which I don't anticipate quite as much issue with dust events from forested land, and only about 3.5% of the land that we have is cropland or developed land. So to have the greatest impact on reducing where we get mobilization of soil particles through wind erosion. The biggest way to do that is to look at how we can improve range conditions. So it's a quick definition of rangeland. It's the lands that are suitable for grazing or browsing use where you're looking at grasses and shrubs. So this isn't your forested grazing land, and this is just kind of your native land that's non-irrigated, that's kind of out there where you see all the cows and wildlife and that kind of stuff. It's these areas that are almost classical New Mexico when you're driving through and see it all. Now, a big issue that we've had here in New Mexico is we've had decades of overgrazing on rangeland in New Mexico that created a lot of degraded range conditions across the state. We're going to get issues like shrub or noxious weed encroachment, such as pinyon juniper, cholla, mesquite, depending upon what part of the state you're in. This also leads to a reduction in vegetation cover, where you could get some sod-bound conditions. And these degraded states make the rangeland more susceptible to erosion, including wind erosion. And that reduction in ground cover, combined with the acceleration of erosion by disturbance from livestock that kind of pulverizes the soil structure and makes the particles more mobile, that means that you're going to have a greater area of land where you can have wind erosion and these dust events happening. Then that movement of soil can deplete plant productivity even further, which increases desertification, and then you get even more wind erosion. So it's kind of like a negative feedback cycle there, or a positive feedback cycle in the direction that we don't want to go. So what NRCS focuses on is improving rangeland health through conservation practices and management. If you look at the picture on the right, even though this treatment's an example on BLM land, many of our programs fill the same kind of role on private rangeland. We go out, we do chemical or mechanical treatment of undesirable brush combined with grazing management, and that can increase both ground cover from native species and plant diversity. The reduction in grazing pressure allows species that had been grazed out to recover, and the improved ground cover not only reduces the susceptibility to wind erosion, but it improves infiltration during rain events, which can continue to increase forage production and increase wildlife habitat. The way that NRCS works is we work with private landowners by providing technical assistance for conservation planning to implement a variety of conservation practices or management systems on working agricultural lands. And then producers can also apply for financial assistance through voluntary cost share programs where they're partially reimbursed for implementation of those practices and systems. The largest programs that we have are the Environmental Quality Incentives Program, which is a shorter term and it focuses more on solving specific problems for a landowner, and the Conservation Stewardship Program, which is a 5-year commitment to install practices and commit to management enhancements on the entire property. As we move forward through the next few years, we're receiving a large amount of money in New Mexico in addition to our normal allocations for financial assistance through through the Inflation Reduction Act, which will improve our ability to target these practices on the landscape and deliver conservation money and get practices on the ground to a wider part of New Mexico. I guess kind of the reason that I wanted to bring this up to the group was to get a sense for if there are some areas where doing kind of a targeted geographic approach to getting more prescribed grazing, more range treatments on the ground would have the greatest effect across New Mexico, and to engage U.S. stakeholders to be a part of the of developing conservation priorities throughout New Mexico. And just to kind of follow up, I do have my contact information here. If anybody wants to talk a little bit more on the side about this, or if you have any questions for me now, I'd be happy to answer those. Also, that link below, Conservation Basics for New Mexico, kind of brings you to the New Mexico NRCS site, where you can get some information about some of our programs and deadlines and that kind of stuff. I know this was a lot more of a broad overview and not quite as detailed as some of the other presentations that were there today, but I just kind of wanted to introduce some of the overviews of what we're looking at and give people the chance to kind of tie into it from that standpoint. So.
Great, Jason. Thank you for sharing that information, that presentation with us and information. Yeah, that's great to have you here today with us to provide that. And so that's some pretty dramatic before and after pictures there as far as the management, the conservation programs. So I can see a lot of need in that area.
And that one's actually down by Roswell. So, you know, this isn't just something that is relevant where you're looking at cool season grasses in the northern meadows, but these are practices that can have a dramatic effect all across New Mexico and even in the drier, hotter south.
And so I do see a couple questions coming in, one from Virginia. And so she's wondering if there's any indication that rangeland restoration is decreasing dust events.
So I have not seen any specific studies about that. It's more of an assumption that as we increase vegetative cover across the wider area, that there will be less mobility from soil because there's less exposed bare ground. So I haven't seen anything to specifically track that.
Great, thank you.
Mm-hmm.
And there's another question from Alan Smith as far as how much loss of vegetation cover from grazing, and then just a bit curious about the scope of the loss of native shrub.
So as far as loss of vegetative cover from grazing, that's obviously going to be dependent upon what species, what kind of rotation we're looking at, and how long they've been through there. But it can be, I would say, somewhere in the 40 to 50% range. And as far as native shrubs, it's not necessarily that we're pushing shrubs that are non-native to the area. You know, pinyon juniper, pinyon pine juniper, Troya cactus, mesquite, those are all native, but they are not necessarily what what a healthy community would look like on those on the sites where they exist after heavy grazing or after other kinds of disturbance. And so it's more tied to the idea that we're getting a degraded state that crowds out a diverse plant community, rather than saying we're getting introduced shrubs.
Great, thank you. And then we have another question and a comment from Morgan Burris. She's saying, thank you, Jason. One of the hot topics in New Mexico right now is the feral cattle and the Gila, and we have ferals in Los Alamos too. Do you see exceptional land degradation and increased dust from the feral cattle?
So I haven't really tracked how much dust per se is from the feral cattle, but what we have seen is we've seen them really pounding down the rangeland right around stream areas and that kind of stuff. We're seeing a lot of increased erosion around areas where we're not able to exclude the cattle from grazing during certain times of the year. So, you know, they're going to congregate around water around areas of increased forage production. So I guess I'm not real familiar with how much damage they're doing across a broad area of the rangeland, but I've seen that we've been really noticing the effects in concentrated areas. And that is something that Adrian down south might have a little bit more knowledge on than I do, simply because most of my focus is from Valencia County North. So I haven't been able to get out around Gila yet. And really with all the fire, the post-fire recovery going on, I haven't been up to Los Alamos as much as I'd like to.
Great, thank you. And so, is there any other questions or comments for Jason? Great. And so I'm going to go ahead and go on to our next presentation. We don't have any more comments or questions for Jason. And so
Thank you all for having me here.
You're welcome. Thank you for being a part of our Dust Symposium, Jason. And so our next presenter is Daniel Tong from George Mason University. And today he'll be discussing dust storms and highway fatalities.
Armando, can you hear me okay?
Yes.
Okay. Hi, everyone. Thank you for having me here. And I want to thank the New Mexico Environment Department for holding this webinar. This workshop is really useful for our community. So I will cover the topic. Actually, it's more of an update of work I presented before, but now it's getting new attention because what happened in Illinois last week. So I'm going to talk about the wind-blown dust event. We all heard Corinne's talk. There's a difference between a dust storm and a dust event. This one, we actually taken both dust storms and also smaller events, and to see their impact on highway fatalities. This work has been a collaboration between George Mason University, including Irene Feng and Julian Wang, and Professor Tom Skill from UTEP, and Kirsten Shipansky from Free University of Berlin. I want to first bring up to your attention of a new paper that was just published by a large team of 28 co-authors, organized by our LASA dust team and also WMO, WHO, World Health Organization, and Pan American Health Organization, PAHO. This one is the first time that we put together a picture of what dust is doing for our local communities. So that's an array of societal impact, including impact on human health, on environmental health, and also on transportation safety. You are very familiar with some of these, such as a valley fever infection, but same things also happen to animals, so that's animal disease. And we have impact on aviation safety, roadway safety, marine navigation safety, and also it's a big impact for solar energy and also probably for wind energy, but that was not covered by this review paper. It's a trigger for harmful algal bloom, and it's also bring contamination to our water or food, bring fungus or other microorganisms to the cities. And for the historical reasons, the dust storm could also bring radioactive materials to different communities. So this is a map that's showing different kinds of vulnerabilities faced by dust storms. Okay, so this is, I'm going to focus on transportation safety here. We want to figure out how many people were killed by dust storms or dust events in the United States. It's a myth because if you look at the natural hazard statistics from the National Weather Service, that we have either 0 or 1 deaths per year. So on average, it's less than it's 1 death per year. But we could have events such as what we all know in New Mexico, you have 6 people killed in 1 dust accident or crash. So what is the difference? What causes the discrepancy in what we know inside the dust community and what the public actually knows? So we look into this problem using 3 data sets. One is the NOAA natural hazard statistics, which is really come from the storm events data set that Corinne was talking about earlier on. We also look at the police accident report from Department of Transportation Fatality Analysis Reporting System, or FAST, and we put all the records together, right, to do cross comparison. If that's redundant, we just remove, we merge in the data sets. So we come up with this single data set, from different sources. If you look, it's very interesting. You look at the natural hazard statistics. This that's a very few, right, every year. But then if you look at the FAST, and you see way more number of deaths in each year. So on average, we have 21 deaths compared to 1 death per year from this new data set. A total of 232 people were killed by wind-blown dust events from 2007 to 2017. So where did this fatal accident occurred? This is the new map which is generated. This map actually was published right now in the BAMS paper journal. So you can go there to take a look of this. This is freely available. The dots, green dots means that's 1 death per accident. And you have the blue triangles, 2 deaths. And then you have 3, 4, and also 5 and 7. We kept at 5 or 7 because for that 11 years we studied, the maximum was 7. Now we know the record has been broken in recent years. So why we see a lot of dust storms in the western U.S., but some of untraditional dust source region, such as the state of Washington, they have dust storms in the spring if that's, the crop is not covering the land. We have 2 hotspots. One is the Phoenix and Tucson corridor, that is 10 miles, and then also Noblesburg here. But if you really look at this across the nation, we are seeing many events that's outside this region. Last year, we were talking about this. This is actually the most updated one we have. So we have events happened in Florida, that's, and also there's one happened in Illinois, was before this event, right? So this is 2017. We had 1 death on that, and now we just see a new record of 7 deaths in a single event. So where did this happen? This is very similar to what Corinne shown for the dust events, but this actually has a very different pattern, especially when you talk about a year to year, and also the daily variations. So from 2007 to 2017, we are seeing a slight increase of the number of fatalities caused by wind-blown dust events. However, I will say this record is too short to tell that's a trend definitely coming or not. Monthly, we are seeing actually more dust storms in the cold season compared to the warm season because of the monsoon impact. And then also in the summertime, and then it's more covered by vegetation. Weekly, we are seeing the the high accident rate on Saturdays, which is not surprising because the U.S. is a country on wheels, and we have a huge truck business that's moving goods around. And almost all the top fatal accidents involved at least one semi-truck. That's something that the trucking company maybe need to pay attention to how to deal with the risk associated with dust storms. And then on the right, on lower right, and this is the hourly, we are seeing a distinct spike around 5 p.m. local time. This is because a combination of a high frequency of dust events and also the traffic pattern. It's the time when people on the road and the dust also hit hardest. And we also did a comparison of the dust fatality to those caused by other hazards, including high wind, thunderstorms, lightning, fire weather, hurricanes. And we find in most years, the blue, which is dust, is comparable and sometimes even higher than other weather hazards. So this is compared to what you have seen in the media, what people know generally about the risk associated with dust storms. This is actually it's a big gap there about the risk actually happened and what has been reported. So I want to spend just a little bit of time talk about the deadliest dust storms in the past 30 years, right? The number one event still held by the California event, and that's in November 29, 1991, over agricultural land. There was 17 deaths and many injuries. The second one happened 2 years ago in Utah. There were 8 deaths. It's also from exposed land, which showing in the middle of the lower bottom. And then just last week, there's another one in Illinois. Actually, it's and also another one over New Mexico. The both caused 7 deaths. Over Illinois, this is the agricultural field again, and New Mexico, there's a player. And also in New Mexico, we have another one that causing 6 deaths in the same location, also of the player. So this is going to be a half an hour town hall meeting organized by Dust Alliance for North America right after this workshop. So I urge you to stay and join the conversation because we're going to spend more time on that and figure out as a community what we can do about it. Okay, so I think this is probably not the slides I should use in this workshop. However, I do think for every dust talk from now on, you should think about using a slide like this and to help spread the word and help to educate our public how to deal with the dust storm. I believe many of these large events, people was caught in the dust storms and they did not know how to work on it, how to deal with the mitigate the risk associated with the dust. So this is something just for the purpose of public education. I would say we need to really look into the poor side and stay alive message, and maybe even develop something that makes sense. For example, there's some actions such as turn off all vehicle lights, take your foot off the brake. It sounds very counterintuitive. So we have to do a better job to explain to people that you don't want, you know, in the darkness when people drive into the darkness, they use tail lights as a guide because they cannot see the road, right? So you don't want to track foreigners in that environment. That's why you should do that. I think this kind of information is really critical and could potentially save life. And this is some information I took from Arizona Department of Transportation. And I hope all the states, you know, including the states frequently hit by dust storm and also less frequently so, should design a plan for such a messaging campaign. Okay, with that, I just want to summarize that we developed a new data set combining two large data sets, the NOAA storm events data sets and the DOT police accident report, come up with this a comprehensive data set showing that we are seeing actually had 20 times more fatality caused by wind blown dust events than previously known. And thus the fatality occurred across the country. Right? It's not just in the desert area. And this, I think, the lesson we just learned from last week is a new proof. And this situation probably is going to get worse as climate change and drought become more severe in the agricultural region. And thus the fatality is comparable as a cause of fatality to other weather hazards that's more well known. And also we should start to help spread the word, poor sites stay alive, something like this. I think this is going to really be very useful public service. Okay, I will end here, Armando. Thank you very much. I will be happy to entertain any questions.
Yes, thank you, Daniel. And so I'm not too sure if this question is geared towards you or maybe like the NRCS, but the question is the acceptance of no-till agriculture by farmers across crop fields in Illinois.
Yeah, I don't think I'm in the best position to answer that question. I wonder, Jason, do you want to give it a shot?
And so there was a comment by David Hadwiger from the New Mexico Department of Transportation that said that the study found that sequential thematic road signs, Burma shave style signs were effective in educating drivers what to do in a dust storm.
Yeah, I totally agree. I think this is a lot of things we are doing in Arizona, New Mexico, and could be borrowed and you know implemented in other states. That's something that we really want to talk about during the town hall meeting.
Yeah, that's what I was gonna mention. It sounds like a good topic of discussion for that. So do we have any other questions for Daniel Tong here? Comments? Okay. And so if you have any other questions or comments, feel free to leave them in the link that was provided before, and I'll write them to the appropriate presenter.
Thank you.
Thank you. And so on to the next presentation, which is me, Armando Paz, with the New Mexico Environment Department. And today I'll be discussing a little bit about the Doñana and Luna County's Dust Mitigation Plan periodic revision, as well as the future of the Southern New Mexico Dust Symposium. All right. So here's a view of our lovely Oregon mountains here in our Mesilla Valley on a clear day. And so this is like a fall depiction of our Mesilla Valley with our A Mountain in the background there. So I'll go ahead and be talking to you a little bit about our revision for our dust mitigation plan, as well as the future of this Southern New Mexico Dust Symposium. So there's a little bit of regulatory information as far as the National Ambient Air Quality Standards, as well as the Exceptional Events Rule, 40 CFR Parts 50 and 51. We'll be talking a little bit about the public health protections, our revision for the dust mitigation plan, as well as the future of the Southern New Mexico Dust Symposium. So I'll just begin with the placement of our PM monitoring sites here in Southern Doña Ana County and Luna counties. So we have 6 PM10 sites down here, as well as 4 PM2.5 sites. And so a couple of our sites have both, such as the Anthony, as well as the Desert View monitoring sites. And so we have to keep this monitoring network throughout, so that we can be able to see the effects of, or monitor the effects of our dust exposure on the populations that are surrounding these areas. And so the number of exceedances required by these monitors does violate the NAAQS. And so I'll go ahead and get onto the NAAQS information. And so for our PM10 24-hour standard, it's 150 micrograms per cubic meter. And so this can't be exceeded on average once a year. So it's compiled in a 3-year average. So it has to be less than 1 for us to be in compliance. And so there isn't an annual standard. For our PM 2.5 standard, the 24-hour standard is 35 micrograms per cubic meter. And in order to be in compliance, it's a rolling 3-year average as well. But this one's based off the annual 98th percentile, and it needs to be less than 35 micrograms per cubic meter or less. And so for the PM 2.5 annual standard, it's 12 micrograms per cubic meter. And so in order to be in compliance, it's a little different. It's a 3-year average of the annual weighted averages instead of the 98th percentile. And this needs to be equal to or less than 12 micrograms per cubic meter or less. And so right now is an interesting time because we're currently at the cusp of a review for the PM 2.5 National Ambient Air Quality Standards. And so right now we're sitting at here in Southern Doña Ana County, we're right there, right about 8 micrograms per cubic meter. And so the EPA is proposing to lower the standard from 9 to 11 micrograms per cubic meter. And so, if they do decide to lower it as low as 9, it will still be in attainment. It's only if they go down to 8. So unfortunately, our El Paso, Texas neighbors are sitting slightly above 9 micrograms per cubic meter. So if they do go down that low, our neighbors will be in non-attainment. So let's see if I can blow this NAAQS stuff out of the way. If it works for me. All right, there we go. Okay, this is a diagram that you've seen many times, and it's been presented. This is, I would say, probably the best depiction of the size of PM, as far as referencing it to a size of hair, and then to beach sand, and then just knowing that the PM 2.5 particles are, like, if you stretch it across a PM10 molecule, you'll have about 4 of those particles stretching across that. And so the severity of impacts, it's kind of viewed as like a triangle. We're going to have the very bottom of the triangle, the pollution, as far as the exposure to the community. And then within that population, there's going to be a smaller subset that are going to undergo physiological changes and subclinical effects. And so this is all based on the severity of the impacts as you're going up. And so not everyone's going to be subject to this. Mostly it's going to be the people who are most vulnerable and immunocompromised. So, for example, the symptoms of illness and the use of medication will be more so geared to those folks, as well as the primary healthcare needs that include emergency services, as well as hospital admissions, and lastly, deaths. And so if you look at the bottom right-hand corner, this depiction is a good indicator as far as the difference between the effects of between a normal healthy adult and I guess you can say a child or a smaller person. The smaller person doesn't have as much volume of air per their body weight. So the amount of oxygen or air that they're taking in within their body or pollution has more of an effect on them than, say, a healthy adult. And so the thing is, I wanted to kind of highlight there is a difference between the ozone pollution, particle pollution, where ozone pollution doesn't have a risk of contributing to lung cancer, unlike particle pollution. And so, I think a good example is the effects of, like, for example, asbestos fiber on our lungs. And so, when the asbestos fiber enters our lungs, we have our natural immune system where it goes and tries to encapsulate it, and it pops. And so, because of that, I guess you can say the shape of that fiber, it keeps having that effect. And so those macrophages are what they're called. Once they start popping and they're not able to actually rid of the fiber, then it'll just keep popping on itself, as well as the particles of those will start creating more inflammation. And so that creates more scar tissue, hence creating more of the chance for DNA structures to become more changed, which can be able to increase the lung cancer risk. And so I'm not going to highlight all the other, I guess, physiological impacts of the different PM particles, like between PM10 and PM2.5. It was already highlighted in other presentations, namely Garin's presentation did a great job as far as depicting the different particles and the ranges for that. And so just wanted to kind of highlight, though, that these our areolas of our lungs, the deep inner lungs, is a efficient transporter of pollutants into our bloodstream. So it goes to other target organs such as our brain, as well as our heart, and also other target organs, as far as if it's like a toxic that will make its way into that, which they all fall into that category as far as PM goes. And so, that, like I mentioned before, the fiber, the asbestos fiber, it creates a condition called mesothelioma, which is a type of cancer. And so there's other types of pollutants, such as silica, which creates silicosis. And so that's another type of illness that is created by a similar mode of action as the asbestos fibers. And so this is just all like the physical properties of PM. This isn't including other types of potential like biological impacts, such as coccispores, which creates the illness valley fever, which is endemic here in southern New Mexico. And so this is becoming more so of a concern as we start dealing with the effects of climate change, and those areas start becoming more expansive. And so the ecological effects were also highlighted by past presentations, and I just wanted to go ahead and highlight the visibility impairments, as well as the radiative influences. As far as the albedo effect, it does increase the spring snowmelt, as well as the decreased plant photosynthesis. It does influence the cloud formation, as well as the precipitation patterns. The sediment transport and deposition is influenced due to the imbalanced nutrient utilization, as well as through secondary pollutants, as far as the acid rain effect. And so it does impact the sensitive ecosystems, such as the diversity of the plants and animals. What happens when we violate the NAAQS? We go into non-attainment, like I mentioned before. And so when that happens, we start having elevated controls, increased permitting requirements, such as emissions inventories, state implementation plan development, as well as possible adverse economic impacts. Our only non-attainment area here in New Mexico is the Anthony PM10 moderate non-attainment area. And so that's the reason for our dust mitigation plan. But as far as being in non-attainment, it's not appropriate in some situations. It's so, for example, when it's human events that are unlikely to recur, or natural events. So we end up having a certain rule that comes into effect for those types of instances, and it's called the exceptional events rule. And so our most I guess you can say use of this rule is for high winds of blowing dust for PM10, PM 2.5. Not so much more for wildfires, but that's not to say if the PM 2.5 NACS changes and we start having more impacts due to that, we may end up going back to past years to start doing exceptional events demonstrations. We don't have too much tornadoes, fireworks, and spills are not so much a concern here in New Mexico, given our rural nature. So there are a couple of requirements, both administrative as well as technical requirements for exceptional events requirements. So first, it's a flag the data in the EPA database. We work with our quality assurance, quality control section and EPA to get all that weeded out as far as what's an exceedance, what's not. So we do have those 24-hour concentrations that are right there at 154 micrograms per cubic meter. So we read those ones out. We include the 155 micrograms per cubic meter. So that's kind of what we're dealing with internally. And so when we submit a demonstration, we want to focus only on the exceedances that have regulatory significance. There's no point on doing any demonstrations for if you're not going to be an exceedance of the NACS. So once we get our demonstration out, we'll submit a 30-day public comment period for any kind of comments for those demonstrations. And so then after that, we'll get concurrence or non-concurrence through EPA with the final regulatory action. And so our technical requirements, we do follow the latest EPA guidance, which was in April 2019. We have to show a clear causal relationship as well as a human activity is unlikely to recur or it's a natural event. So in our case, it's a high wind blowing dust event. And so we also have to prove that it's not reasonably controllable, preventable. And so this is for recurring events. So for example, our mitigation plans. And one other jurisdiction in New Mexico that does require mitigation plans is the County of Bernalillo. So we do have some public health protections, and this is geared towards the most vulnerable at the risk population. So our children, elderly, as well as the immunocompromised. And so this is for Doña Ana and Luna counties for PM10 NACS exceedances. Like I mentioned before, Anthony was the only non-attainment area here in New Mexico. So we're wanting to keep it that way with these demonstrations that we're submitting. And working with our dust mitigation plan to keep the most vulnerable protected. We do have a fugitive dust rule, Part 23, which is applicable to those areas that do are required to have a dust mitigation plan. So Banana and Luna counties. We do focus heavily on our education, outreach, and collaboration. So we do piggyback a lot on our sister agencies, such as the National Weather Service, our New Mexico Department of Transportation, or BLM. So I mean, this is a big component as far as the collaboration and outreach goes. We do provide our air quality indexes daily. We have an online monitoring website where you can be able to check the daily, hourly air quality indexes, be able to make health-based decisions based on that. And so for our dust mitigation plan revision, it's required for areas with the recurring PM10 NACS, and this is under our Clean Air Act, Section 319, under the 40 Code of Federal Regulations 51.930. And so this is, we're wanting to revise it and average every 3 years or as needed. So our last revision was submitted in March 2021. And our initial dust mitigation plan was submitted September 2018. And so we are planning for a 30-day public comment period this, I guess it's this fall. We're going to be going through that process and going to update the public notification and education programs as we've kind of evolved and adapted to different to the differences from the previous dust mitigation plan, as well as mitigation measures as well as stakeholder engagement. And so I know that since then we've created a new stakeholder engagement organization, which the Dust Alliance of North America. And so with our Southern New Mexico Dust Symposium, just we're ordinarily having every spring and fall, and so a plan is to at least have it every spring. It is getting a little hard to be able to have a fall one to be able to, based on the demand, as well as here in control strategies, our section is getting pretty heavy with workload. So, the projects do need to kind of take the first and foremost priority. So, we don't want to lose any kind of traction as far as our Southern New Mexico Dust Symposium. We would like to maybe invite other organizations and maybe have a joint multi-jurisdictional symposium, maybe even for that fall. That's been proposed by Arizona and other partners. And so we'd like to include Texas, Colorado, Arizona, maybe even Chihuahua, and our joint advisory committee. We'd like to get the word out to them as well. Our folks from the Dust Alliance North America. We do have engagement with our Westar and RAP agencies, our folks, organizations from there. That's for like all the Western states. It's a Western Regional Air Partnership, and so it's pretty much all our planning folks from the Western states. And so another idea is to have a multi-pollutant approach. I know ozone and regional haze are kind of a hot topic as well, as we're starting to become more familiar with these programs. I just want to kind of cautiously approach that. Just don't want to get kind of snuffed out with some of these other pollutants, because they are some hot topics, and there's a lot of information regarding that. So I would like to keep this as part of like our public engagement stakeholder series, and we've had 3 other ones this past year that revolved around regional haze in the Four Corners area. I guess our whole goal is to be able to use our best available resources to reach the biggest audience and provide the most up-to-date information, being that we're a small, tight-knit group. We don't have the most resources. I feel like we can make the biggest punch by us all coming together and putting our heads together and being able to utilize our resources as best as we can. And another idea too is maybe creating a steering committee, and maybe having a in-person hybrid meeting, which I know it's a little difficult to think because we're all coming from different avenues, being pulled in different directions. But I could use some help to help organize some of these events, and I'd appreciate that. Whoever's willing to volunteer. And so, yeah, I mean, our this is also what we're this is the Gila monster is what we're also protecting, because I'm heavily geared into public health, and so to try to think outside of that and try to think about our other species that are being protected by our Clean Air Act. The Gila monster is one of them, being a sensitive endangered species of the desert Southwest uplands. It's vulnerable to the effects of climate change due to the potential decrease in the monsoon season water allocations. And so if these uniquely venomous lizards don't receive enough water in between the spring's rains and the monsoon season, their ability to survive decreases. So this past year's April showers were pretty dismal. And so hopefully we get an early monsoon season for their survival. And so the dust impacts combined with the greenhouse gas stretches far and wide with the effect it has on the hydrological cycle and the terrestrial species that are affected, all the way up from the alpines down to the desert floor, such as the case in our buddy, the Gila monster. So just be careful. Don't let that smile deceive you. His bite is pretty painful. It's best to keep your distance. But not like us here at the Air Quality Bureau. We're always open to engage, and we won't bite. My contact information is provided if you'd like to contact me. So, thank you.
Good job, Armando. We did get a question from Virginia. She asked, what practices are being explored in the dust mitigation plan? Has anything worked particularly well?
Yes. And so, like I mentioned, our piggybacking off our sister agencies who are very good at what they do, getting the word out. So, for example, the National Weather Service, they do issue the blowing dust advisories. The New Mexico Department of Transportation, they do get they do have their advisories as well, and they have it publicly posted on these areas that are more prone to the impacts of the the dust erosion on the highways. We work with the BLM as well as other agencies that are good at being able to do these types of projects that are like reseeding or revegetating or other types of methodologies that help reduce the rate of emissions from these more susceptible areas, such as our Lordsburg Playa. Our Lordsburg Playa is a pretty big area that releases a lot of emissions into our area whenever we have the meteorological conditions favorably coming from the southwest direction. We we rely heavily on our agencies such as that to shine in the work that we do. So we would like to get more people involved in those areas to be part of the symposium to share with the work that they're doing. And so I invite those to give suggestions or input as far as how we could strengthen our dust mitigation plan. And so I kind of feel like it's working favorably well. I mean, as far as us being able to get the word out to minimize the incidence of the impacts and not have our pileups being so severe, as well as like getting the word out to our. We could do a lot better, I guess you can say, as far as getting the education outreach component as far as to the most vulnerable communities. And so there's some ideas out there that we would like to explore further, like maybe working with our more local like public health promoters who go out to the community and are actually face to face with some of these folks who they can be able to. They do health screenings and health fairs, and so we would like to be a part of that as well, as far as having our presence out there and getting out and educating the effects of particulate matter. I did a career fair for my daughter's school, and the sixth graders they're really interested. Well, I should say all of them are, especially the eighth graders, the ones that are kind of going into like high school that are in these STEM programs. They're really keen on a lot of the information and the outreach component to that. So thank you for that question. Is there any other concerns or questions?
Armando, there was just one comment. I think it's kind of pertains to several of the presentations on regenerative agriculture. Alan Smith had posted a link from the NRDC of some strategies.
Great. Thank you. Yeah, we'll incorporate everything we can and try to get everyone on board, because I know we're all kind of stretched pretty thin, and just to try to keep the momentum going, and we can be able to, each one of us shine in each of the projects that we do to keep, be able to make the impacts that we each can do. And so, yeah, if there's not any more questions or comments, I think we can.
Can I say, you mentioned that you have identified the.
I'm sorry, Ramesh, I can't hear you very well.
You're not able to hear me?
Not very well.
Oh God.
Here we go.
Okay. Let me see if I can. Is it okay now?
Yes, I can hear you.
Yes.
Okay. So you mentioned that you deployed PM10 sensor and PM2.5 sensor. But these days, you can deploy one sensor which can measure PM1, PM2.5, and PM10. Why do you deploy the two different type of sensors?
Yes, that's a great question. We, as a regulatory agency, we have to abide by the Code of Federal Regulations to meet the federal what is it called? Federal equivalent or federal they have a certain standard for the monitoring stations, And so they're federal regulatory monitors. There you go, federal regulatory monitors or equivalent. And so there's a certain minimum requirement that is needed to be able to meet that. And it is very expensive, the monitors that are needed to be able to meet that requirement. So that does kind of point to another need, and as far as low cost sensors, and to kind of help fill that data gap, and maybe even like kind of help, co-locate as well as fill in that data gap. So here along the our Paso del Norte airshed, which is the airshed that is between El Paso and New Mexico, El Paso, Texas, as well as New Mexico, as well as Chihuahua, Mexico. We have a network of low-cost sensors. There's a study and project that is currently going on over there, and we would like to. That's another thing that would benefit us here in southern New Mexico, as far as like what's an idea on the list, as far as getting some funding for us to be able to work, or maybe even work with other partners, maybe like the school districts or whatnot, so that we can be able to get more low-cost sensors out to help maybe educate the public more, as well as maybe even potentially being like a segue as far as getting the conversation started. That's another strategy that maybe is on the list. And so if we can be able to get more funding to be able to increase that network, that would really strengthen our outreach and education component.
So what type of sensor you use and how much it costs?
Yeah, they're pretty expensive. I would say to get one up and running, we are currently getting our first. We've just currently first got our first air sensor up in Juarez, Mexico, and with the first year, as well as like the monitoring, like the maintenance plan, it's coming close to about 100,000 to be able to get that one started and be able to have it running for at least a year, 6 months to a year. So that's like the upfront cost of getting it, like the overhead as far as getting it started, built, as well as to be able to get it manned and like the consumables and everything going for a good 6 months to a year. So that is kind of out of the reach of a lot of communities in New Mexico, especially our low income and vulnerable communities. So I feel like the low cost sensor project would be a good strategy for us to be able to incorporate.
This is a very expensive sensor you are using, and these days the low-cost sensors, and I try to validate this with the U.S. embassies. Okay, they have deployed a air quality monitor at different embassies in India, China, and other places. So, thank you.
Thank you. So I got a question about from German Rodriguez, where the water sensor will be located. And so it's located in the southeast part of Juarez. I'm going to go ahead and see if I can bring up the map to show where it's located. Actually, I'm not going to be able to get it up quite yet. But yeah, it's in the southeast portion of the city. It's at a health club. And so I was really kind of as much as I can say that I'm heavily into particulate matter, I was really kind of hoping that we could be able to get an ozone monitor out there in the Anapla area, as well as like the San Jeronimo area. But Hedman, I recommend for you to stay up to date with us at the JAC. You're more than invited to attend our meetings so that you can stay up to date with all our projects over there. And I can go ahead and forward some more information to you if you're interested in others as well. But I feel like we need to kind of get on with our agenda with the town hall meeting. And so if you have any more questions or anything, feel free to forward them to me, or even, we have that link for different questions for the different presenters if you have anything that comes up later on after the symposium. So with that said, I'm going to go ahead and go forward with the starting the town hall meeting. So I'll go ahead and hand it off to Dana.
Thank you, Armando.
Good day, everybody. I'm Scott Van Pelt. I'm currently the president of Dana, and it's not the same world into which we were born. Things that used to happen on a regular basis are no longer happening, and we have weather phenomenon that we've never seen before that are happening with great frequency. And so it is with wind erosion and fugitive dust causing problems in parts of the country where it just hasn't previously been seen. I pulled up a map developed by NRCS showing wind erosion and water erosion around the United States. And in the state of Illinois, there are simply no red dots indicating wind erosion being measured there. There are a few in northwestern Indiana where there's some very sandy soils coming from the dunes along Lake Michigan there, and also for organic soil some places in the east. But for most of the farmlands in the Prairie Peninsula there, it's just not showing wind erosion. But we know that there is a problem there. 7 people lost their lives there in the last week. Many more were injured, millions of dollars in property damage. And it comes to a point where we need to stand and pay attention to this and decide what it is maybe we can do to bring people's attention to this and to prevent these things from happening in the future. And with that, I'll hand it off to Daniel. I think he was going to be moderating this, and I was just supposed to give the welcome from Dana and go from there. Daniel?
Thank you, Scott. Yeah, we appreciate you, your leadership, and this is a great opportunity, I think, for everybody to get together to share our thoughts on this historical event happened. We have never seen this actually in the Eastern United States. So I have prepared a very brief agenda just because we only got 30 minutes, and then I also want to give people a chance to talk about it. So this is how we are going to do it. After this, we're going to adapt the topics that we're going to, because everybody needs to have a say about NET. And we will show you a list that we have and also invite you to contribute. With that list of topics confirmed, we will go ahead with discussion. Because we have such a short time period, what we will do is we're going to use a Jamboard, which I will do a small demo, combine that with the small speeches. For each speaker, if you are going to talk, please be aware of the time limits and maybe 1 minute or 2. And after that, we are going to have a summary. And also the thing we really want to get out of this town hall discussion is to combine a list of potential actionable items that we could promote either through Dana or in collaboration with other organizations. Okay, with that, I'm going to show, put in a link of the Jamboard here. Give me 1 second.
I went ahead and provided it in the chat.
Oh, you already did. Wonderful. Yes. Thank you, Armando. Okay, so what we will do here is after we confirm the list of topics, we're going to have several slides. For each slide, we're going to have a name, have the topic here. So for example, what is unique about this dust storm? And I want everybody to be gracious, not to override anybody else's writing, but put your own thoughts here, okay? And with that, I also want you to add your name here, full name, because if there's some follow-ups, I would hope to follow up with you and then also attribute proper credit to your thought, okay? So this is the first one, what is the unique about the dust storms? And you can use the arrow to move to the next one. What is the next question? Okay, so you can put your thoughts there and so on. Okay, so this is how we are going to do the discussion. Okay, I will move back to my slides on the agenda. Okay, so next I'm going to move to adoption of town hall topics. The Dana Executive Committee has come up a list of questions here. However, this by far is not a complete list. So I will invite everyone right now to type your suggestion of additional topics in the chat. We'll have somebody monitoring the chat, and I can put that back to this slides. I will take give everybody like 1 minute to think about it, and if you want to type, we'll wait here.
Daniel, I'm unfamiliar with WebEx. Where do we find chat?
Okay, good question. Amanda, are you familiar with that? I'm actually not so familiar. I believe I found it on the lower right.
Yes.
That's like a conversation symbol.
The balloon. Okay, yeah, good.
Daniel, could you repeat the task or the question?
The task is any additional question we want to discuss today, other than the one listed here. Those are the current questions. Okay, I think it's time for us to come back to the agenda. I will go ahead with the first question. Okay, so we'll discuss the first question where you can continue to put your thoughts in about the topics, any new topics you want to cover. So the 5 questions we ask here is what caused the dust storm? What is unique about this storm? What can we do to prevent future dust casualty and injuries like this one? What are the knowledge gaps to issue early warnings and to mitigate dust risks. And the last question is what resources are needed for researchers, for practitioners, and for the public reach people. So with that, we are going to move to the Jamboard, okay, which you can find from Amando's link here, which I will put here again. To the first one, okay, and the first one is to look what caused the storm, and we're going to and we'll give everybody maybe 2 minutes to write down your thoughts, what caused. Sorry, the first one is what is unique about the dust storm. And put your thoughts here on the first slide of the Jamboard. And after that, we are going to have open mic discussion. Okay, I do not see any additional actions here. I think we want to go open the floor for thoughts. Anybody want to talk about what you wrote? What is unique about this one?
As I mentioned earlier, I think the thing that really made it newsworthy in the national news, other than the loss of life, was just how unusual it was for this to happen someplace that we normally consider to be a humid environment with a lot of growth year round, and that being Illinois. For those of us in agriculture, we're constantly being told we need to plant cover crops for the sake of the soil. And here in the Southwest, that's kind of a losing proposition. But in the Midwest up there, they have enough rainfall year round to support that. And I read through a blog that was put out by a soils professional that said those soils were mapped as highly erodible by NRCS. So that begs the question that I threw up on the board a couple of minutes ago.
Yeah, thank you, Scott. You can either unmute yourself or you can raise your hand.
Daniel, Ramesh. Okay. I saw that so many cars collided, and as a result, 7 people died. Right? Okay. So I tried to look the satellite image, and I did not see the source, how this dust was developed. Okay, and only what we saw in the freeway. Okay, people they experienced this. So did we get any warning of the dust? And I would like to know about the wind velocity and wind directions. Okay, and so in order to mitigate this, we should have all these parameters are very important. What about the visibility? Okay, so nobody noticed, and people were driving cars with so much speed.
Yeah, thank you, Ramesh. I will invite the people from the weather service to comment on it. But before that, I just want to say this small event, like what happened in Illinois last week, was very hard to predict. So for warnings, I wonder, Glenn or anybody from the weather service like to comment on the early warning issues?
Hey, this is Glenn. Can you hear me?
Yeah.
Okay. Yeah, I didn't quite catch the full question, but I could talk a little bit about warnings for dust. I know in this specific situation, our colleagues at the Lincoln, Illinois WFO, they did put out a blowing dust warning. There's two ways we could issue warnings for dust, and usually like the shorter fuse dust events that we think only last a few hours, we could put it out in such a way that it'll go out to cell phones. That is not the way they issued it on the day of the actual accident. The following day, they did it that way. The way they actually did it is just via an internal mechanism that it's called a blowing dust warning, and that's usually for like a longer fuse event than the shorter fuse dust storm warnings that go out to the phones and everything. So it's my understanding that in the Illinois case, that for that local National Weather Service office, that was their first time ever issuing any kind of dust warning. So they might not have been quite familiarized with some of the best practices that we're used to in the Western U.S. But when it comes to major incidents or significant blowing dust, here in Arizona, our typical way of issuing is to get it out, via the wireless emergency alerts to people's phones, since that is the best way to get widest distribution of warnings for dust.
Thank you, Glenn. But Glenn, while we have you here, I want to ask you. You said this is an anonymously strong wind event. I saw the wind speed was 35 to 45 miles per hour. Is that typical in springtime in this region?
Yeah, I mean, I was probably a little bit loose with my language. I would assume it's a little bit on the strong side, but I mean, I haven't actually looked at the data for sure to know just, obviously it's pretty gusty. Seems like to me, just basically looking at the weather pattern, that the gradients were tight, but I don't know just how anomalous it was. So, but certainly, I mean, 35 to 45, just like we see in the desert, that's enough to get the dust going off of the agricultural fields and the plies and whatnot. So similar situation up there. And I know they were in a longer term drought. So like I said on the Jamboard, I think it's just a kind of a confluence of events. Time of year with the spring green up, I assume that didn't really get going yet. And with the drought and the winds, it was just the perfect combination of events that, to create the dust there in central Illinois.
Yeah, thank you. Yeah, so the other question that Ramesh was asking was, what is the source of this dust event, dust storm? Is anybody like to address this question?
I guess I can handle that. This is Scott. And one of the problems with commercial tillage of soils is that we tend to aerate the soils and we break up the aggregates such that microbial decay of organic matter happens much more quickly. And so tillage has been shown here, particularly recently, to be a degrading process. And that's why a lot of soil practitioners are advocating for minimal tillage and for including cover crops to protect surfaces during the fallow period from the normal economic crops. And this helps build the soil and particularly keep the soil into larger aggregates, which are basically unerodable by wind.
Yeah, thank
So
you.
the fields that were blowing were those that have been commercially tilled for a number of years.
Thank you. So Ken Miller, are you still here? I saw you posted something in the chat, talk about driving through this area multiple times, or many times. And Ken, are you still here?
Daniel, can I ask Scott, because Scott is talking about the soil, there was no like agricultural crop in those farms, only the soils, the barren soils? Scott?
Yes, generally the most protective cover on a soil surface is a growing crop, and that serves a couple of purposes. First of all, the crop itself protects the surface from the wind, and the other one is that the roots of that crop tend to hold the soil together, and particularly in an environment such as Illinois, where rain comes moderately frequently and sometimes in small amounts, the roots can be very close to the surface. Did I answer your question?
Yes, but we have to see whether there was no rainfall before that, okay, and the temperature was higher, because when we are talking about the dust, you see, if it is dry, then only the soil is going to lift.
Yes. Now, one thing to keep in mind is that roughness is one of the best ways to control wind erosion and dust emissions. And if the soil is tilled and it is rough and a rain comes, a lot of times, particularly on a degraded soil that's been over-tilled, the aggregates will break down and you will end up with a smooth, slick surface that is highly erodible by wind. And in soils that are categorized by NRCS as being wind erodible, this is generally the case, is that it doesn't take much rain to destroy any aggregates and leave a very smooth and highly erodible and emissive surface. And it doesn't take very long after the rain either. I've got pictures of water standing in furrows and dust being generated off the tops of beds.
Thank you, Daniel. Tom, I would like to hear from Tom.
Yeah, Tom,
Yes.
please go ahead.
Thank you. Yeah, in response to a couple of the comments and then leading into an idea of my own about best practices. Of course, I was not there, but I have read like on some blogs and reports that in this specific situation, some of the crops had just been planted and had not really germinated yet. So there was really no vegetation on the surface to hold the soil down. So it was kind of that very short period when the soil was bare. Also, again, I have seen reports from the climatological authorities in the area saying that that region had been experiencing a short-term drought. And as Scott said, even a short-term drought in an area of a humid, wet climate can cause really a drying out of the soil. And as Scott said, the soils in that area were mapped as highly wind erodible. So high winds, short-term drought, crops not growing there yet, wind erodible soil, it's not too surprising. And in fact, to follow up, I came in a little late on this, so maybe Glenn already mentioned this, but I had looked back to the local National Weather Service office in Lincoln, Illinois, and that, at least the general, maybe not that specific dust event in that location, but the general probabilities of dust was well forecast, even like a day or two before in the forecast that the local weather service office put out. They did specifically mention strong winds, which would act as crosswinds along the major highways and would lead to areas of blowing dust blowing across the highways. So this event was forecast, and I think it was actually forecast pretty well by the Weather Service there in Lincoln, Illinois, for an area that doesn't normally get dust storms. But that leads into a thought of mine. Glenn mentioned best practices. Of course, here in the Southwest, in New Mexico and Arizona, when there are strong crosswinds, dry conditions, and dust producing conditions are forecast, Glenn, I don't know exactly how you coordinate it with the agencies, but I know like quite often Interstate 10 is actually either shut down in parts of Arizona and New Mexico before or when the dust starts, or if nothing else, there is a very strong highway patrol presence along the major interstates, in some cases to keep traffic going slowly, guide them through dusty areas, and so on. And what I'm wondering, partly because this is a very, very uncommon occurrence in Illinois, I've seen no evidence one way or the other, but I'm wondering if, there was there thought of closing the highway since it was known that dust was predicted, or was there plans to have a much higher highway patrol presence on that stretch of interstate to maybe keep the traffic slow or to cause escorts or closures or not? And I'm wondering if that might have been a factor in this incident, just because it's not something that the authorities in that area would commonly expect to occur, like we see in Arizona and New Mexico.
Yeah, Glenn.
Yeah, so wanted to address what Tom was saying regarding, how does the National Weather Service coordinate with partner agencies such as Department of Transportation or Department of Public Safety, whose, their main priority is keeping the highway safe. So most of the time, and I could only really speak to what goes on in Arizona. I mean, the National Weather Service in El Paso and Albuquerque would, they may work things slightly different in New Mexico. But for us, anytime we issue a dust storm warning, one of our first calls is to the State Traffic Operations Center. We do directly talk to the Department of Public Safety officer on duty to let them know that we've issued a dust storm warning and the particular mile markers that we're concerned about. So that does give them the heads up. That does not necessarily mean once we put out a dust storm warning that they're going to close the highway. In fact, they usually don't. The times that I've seen that they'll close the highway is when, for example, there was plots of land around San Simon a number of years ago that were known to be trouble spots on any windy day in the spring. They would reduce visibility to nearly zero, and there have been a bunch of accidents in that area. So that's one circumstance that we would issue, and I can recall that they would more or less close the highway as a result. But most of the time, I think they just take what the warnings under advisement. They probably do increased patrols, and if they think the conditions will get bad enough, then they will close the highway, or if there's an accident.
Thank you, Glenn. So we are going to take one last question on this topic before moving on. I saw one from the chat. Saroy Dishale asked any idea of the large-scale meteorological precursors to this event. Anybody want to address that?
I think Tom covered that pretty well with the timing of the cropping season, the fragile soils, and the drought mixed with the unusually high winds.
Yeah, I think there was a short-term drought that had dried out the soils a lot more than usual. And then meteorologically, I haven't looked at it in detail, but I understand there was a stalled and/or intensifying low pressure area that was causing very strong pressure gradient and strong winds. And that's also the same thing that is a great recipe for dust in the springtime in the Southwest.
Thank you, Tom and Scott. Okay, so we're for the benefit of time, we have to move on to the next question. This I want to, I hope we can address three topics here today. So we are going to move on to the next slide, which is what are the knowledge gaps for early warning and emergency responses. You can just use the arrow advance to this is the first one, this is the second one. Okay, so this is the topic right now we are writing in the second slide.
So one thing is very clear from the Tom and Scott that this was a local dust near Illinois. Okay. Any comment?
It was local, but it was not as hyper local as some of the events as we see. Some of the satellite agencies have actually posted satellite images showing that you could actually see dust on satellite in central Illinois on that day in several locations and several times. So, you know, when you have dust that is visible on satellite, it's not strictly a hyper local situation.
What type of sensor image you're talking about, Tom?
I don't have it right at hand. I believe it was from CIMSS
Yeah.
and or CIRA had actually posted satellite images from several satellite sensors actually showing the dust in central Illinois.
Okay, thank you.
Okay, while you are still working on that, maybe we can start with a discussion. I saw Michael Baker put the Go 16 images in the chat. That's from the National Weather Service website. Okay, anybody like to start a conversation on the second topic? What are the challenges? Okay, I can start share my own thoughts. So over the years, I have been doing dust forecasting, and always found this kind of I call it killer dust events that cause a lot of a high number of casualties. It's very hard to predict because they are not like this large scale storm that you can see it from far away. But this storm come from near highway source, and you really have very little time to respond, and it's out of a region that's not typical for dust storms. So people are less experienced compared to people in Arizona or in New Mexico. So that said, I find that there are two outstanding challenges from a forecaster perspective. One is it's hard to represent the dynamic surface condition change. For example, after chilling, right, or like dry lakes, for example. So those are the challenges that we are unable to represent in a model in near real time. The second one, I think, is on the decision-making side, that if you predict a dust storm, right, we all know that all the models can be wrong, right? And you have only limited amount of information. You have to make a decision that's going to impact people's lives, impact the commercial. So it's a hard decision to make. So how do you determine the probability of a dust storm to cause a fatal crash? This is just very difficult for the forecaster to decide, and also for the decision makers to decide to close the highway. It's just my thought. I wonder, any of you have anything you want to share about some of the challenges?
Daniel, when you say that it is killer, I don't think I will not say that the dust storms are killer. The question is here in the highway, there were the traffic and the people were driving with the high speed, and this is why the visibility became poor, and then the cars were collided. So most of when we are talking about the health effort and effect, okay, what I did mention, and also Amanda, he talked about this. This is because of the PM 2.5 and PM 10. Here, due to dust storm, the visibility was so poor, and people were driving at the same speed, and then the cars were collapsed. I will not say that dust storms are killer.
Yeah, that's a good point, Ramesh. I think that it's just a very common argument. People said, dust storms do not kill. The people kill each other, right? But I think the impact of dust storm here and wind blowing dust events in general is that it changed the conditions. So, for example, the visibility, right? It's a big impact. That caused people to panic and make wrong decisions. And because of no visibility, you cannot see things, so you cannot make a decision. That's that decision will kill people, right? In a sense, that you are right. And additional factors is that the powder deposited on the surface sometimes is thin, is thick enough that can change the traction of the road surface. That you actually need a longer distance to brake, right? So that's if you do not remember that will kill. So there are it is debatable about what can we call a dust storm be a killer, or is that people kill each other. I think at least here that dust is a major factor that causing those car accidents. And this is also different from high wind events in which you have high winds but you still have a good visibility that you can make reasonable decisions.
I think one of the factors also is that dust comes up so suddenly and without any sign that it might be there. When we lose visibility due to heavy rain, we've been watching the rain clouds form, the skies darken, and so we're preparing ourselves mentally for that. The other thing is that this is something that would take a lot of time, a very long time to integrate into the population of active drivers, but education of what to do in the case of a dust storm. A lot of people would tend to pull off the side of the road and then keep their foot on the brake, and that's a bad idea because other drivers might say, there's some taillights, I can follow them. And so, there's specific procedures that have been developed, but I know that no place that I've ever applied for a driver's license where I had to undergo a test, were there any questions or actually anything in the driver's manual about how to deal with dust storms.
Yeah, thank you, Scott. So for anyone who shared your thoughts on a Jamboard, do you want to speak about your point? Okay, if not, for the benefit of time, we just move on to the last topic, which is really what we want to get from here. What are the actionable items? How do we prevent future similar events? Okay, so I will invite you to put your thoughts here. Again, please put your name here first so that we can follow up with you just in case. This is still on the Jamboard, but on the third slide.
So Daniel, as Scott pointed out, that when we see such dust, we should have stopped. Okay, and suppose, like always, we see tornadoes, and people they try to escape or they change. Okay, so why not when the people they saw that they just stopped, they should have stopped. Okay, not driven. That is the best practice. One should do that.
Yeah, that's a good point, Ramesh. I agree. Just when people see that, they should stop driving and pull aside, just wait it out. But this is probably it's when people are driving like 80 miles per hour, it's hard to stop for one. And it's, as Scott mentioned earlier, it just came out from nowhere, and you have very little time to respond.
Yeah, Daniel, I just wanted to go ahead and point out that during certain times, whenever conditions are really bad, we have a section over here between Deming and Silver City that gets a portion of the state highway that gets closed every so often because of how dire the conditions are. So that's I never been out in that section during those dust storms, thankfully, but I guess the conditions are so bad that they just have to completely close that section of the highway off, and it's probably a good at least 30 mile section, so it's not a small little section that's need to be closed off. But I would say that's like probably like the worst case scenario as far as like what is needing to being done. I mean, for the protection of life and property.
Yeah, it's a hard decision to make too. Unless you already know for sure. The forecasting part is like really hard to decide. But if it's something we already saw something, and you have a camera, you have visual evidence, and you can make a decision much easier.
I would like to ask, such event has also taken place in the past. I believe this is very rare. So many people died. You know, anybody knows? about such event?
Are you talking about Illinois?
Yes, yes. This such
Yeah,
event.
this happened before, but at a much smaller scale. In 2017, there was an accident killed one person in Illinois, and there were several other dust storms caused injuries but not deaths in that state.
Yeah. They are unfortunate. Because the people they die when they uprooting of the trees and falling of the electric pole. Okay, but here it happened on the highway when they have so many uh, vehicles collapsed. That is the main drawback.
Yeah, that's true. Okay, so I'm going to spend the last 5 minutes just dedicating this to the discussion of how do we prevent it. I will start with David. David, I know you have been working in this field for many years, and you have a lot of good thoughts. Please, if you don't mind, could you elaborate your thoughts? I already took the liberty to put your comments that you found the sequential thematic road signs were effective in educating drivers. Do you think this is what they should be doing in the eastern states?
I don't see David here with us.
Okay, he already left.
Yeah.
Anybody has any thoughts on his idea, like of this putting more signs in other states, other than where we already had it?
I mean, I think if there are known dust-prone areas, which is the same thing that happens in the western states, but if there are known dust storm prone areas, there's no reason why not to put those signs anywhere.
Hmm. So this sign is set up is put out by the state DOT, or is any other or other agencies? Or
Here,
the L
yeah, here in New Mexico it is. So they have signs along the highway, as well as the interstate, indicating the areas that are really prone to dust storms, just to give people like a warning. And so, like the ones on the highways, they're kind of like real time, like the digital ones, like and the ones on the state highway or the state highway. That one's just like metal signs that are always there posted.
Mhm. I see. Yeah, it's probably something that we should follow up on, and how do we talk to the right people to do this if this is what everybody thinks is the right thing to do.
That was my thoughts. That's at least in that stretch of the highway. I mean, it's unfortunately it's kind of like how I see signs are kind of the decision to put signs up are usually whenever there's already been like some type of event that's already occurred. And unfortunately, there's usually an injury at the very least that usually gets somebody to make that decision to put signs up for whatever it is. I mean, whatever kind of hazard it is, but in this case, being dust.
Yeah.
I'd just like to reinforce a little bit what I said earlier that goes here is that there needs to be a high awareness for like coordination between, let's say, like the weather service or weather authorities and highway and transportation authorities when there are dusty conditions forecast that would affect major highways. And, maybe it's not this, it's the sort of thing that happens routinely in Arizona and New Mexico, but may need some sort of like better practice or reminders in some of these other areas that get dust storms less frequently.
Mm-hmm. Absolutely. Yeah, I agree. I saw Scott also put notes here about the same thing. So I want to under is Mara Hannenberg here. Do you want to talk a little bit about your ideas of educating farmers on ways to reduce wind erosion?
Yeah, this is not my area of expertise at all. But for other folks here that this is their area of expertise, it seems like there are things that can be done at, a farm scale level to try to reduce the, susceptibility to wind erosion. We already talked a little bit in this particular event that there weren't like active crops growing at this time, and so it was a combination of multiple factors coming together. But definitely, I think addressing the source area. But again, it's not it's this farm, on this event, but it could be a different location in a different event. So it's more of a large scale thing.
Yeah, thank you for sharing your thought. Okay, Mark, are you still here? You mentioned you wanna raise awareness, including best practice. I think that's a good idea, and feature more on drivers' education and defensive driving trainings. And do you mind elaborating your thoughts on this?
Well, this is Mark Jones. So I just had to take a regular defensive driving class with the state of New Mexico. We have to do it every, 4 years. And it was a really good class showing some of the hazards with like driving and whatnot. I don't remember, dust being really featured or dust or those kinds of events like on the highway being featured. And so um, I'm not sure how it would be done or implemented, but I think that if something like that could be maybe integrated into like defensive driving classes, it could possibly provide some additional, some of the people would have additional knowledge about what to do in those particular instances. And then, once you educate some people, they then can pass that on to others. So that was just my initial thought on some of the possible action items.
Yeah, it's a very interesting thought. Thank you, Mark. Okay, I want to maybe because we are almost over the time, I want to give the mic to Virginia Gavin. She's been a great reporter for our community. Thank you very much for doing that, Virginia. Do you want to take this time to share your thoughts on this? You probably are so well studied, better known. You know better than most of us now.
Oh, hardly. But hi, everyone. I always appreciate being able to join and see what you're working on because it helps me generate story ideas. I guess when I have done the few dust stories that I've done over the last couple of years, it kind of always, my editors are always very curious about what are the legal ramifications of these, especially these big events where unfortunately there's lots of fatalities. Is there any concern that there is going to start being legal ramifications or culpability for especially farmers and land managers? And so, I just found this other story that another colleague wrote just a couple of days ago. And so, I think that gets it kind of the same, like we're in the same mindset of this seems to be a very big, or a growing concern amongst land managers is like, where is this going to lead, especially when we start seeing fatalities and things like that, and people understandably get upset, especially when we know that there are land management tools that can help reduce or mitigate dust. Obviously not always. There's always going to be time when you're working the land if you're a farmer or what have you. And so how do you thread that needle of what's responsible land management? I think that is a concern that, editors continue to bring up to me is just where is this headed? So I just wanted to throw that out there.
Wonderful. Thank you very much, Virginia. All right, I think we are about to close, 5 minutes behind. But if there's any, and this is the last chance, if you have any burning topic you want to bring up or burning thought, please unmute yourself. Okay, very good. Well, thank you all very much for joining the Dana Town Hall. I also want to thank Armando for organizing this workshop and give us the platform to speak with you to discuss this really important topic. Amanda, I will yield the mic back to you. Armando, sorry. It's just
Thank you, Daniel.
it's a late afternoon for me.
Yeah, that was a very good discussion we had there. So glad we were able to come together and discuss all these different ideas. So it'd be good for us to keep it rolling. And just if you have any more questions or comments, feel free to forward them to me, and we can keep the discussion flowing. And so, with that said, we are at the end of our allotted time for the Dust Symposium as well as the town hall meeting. And so I do appreciate everyone being here today and coming together and sharing. Your work that you've done. And so it's like I mentioned, I'm always very excited and proud to be able to host these events. And so I'm looking forward to our next one. And if you have any ideas as well, how to improve, or you want to be part of the steering committee, or just feel free to contact me. And so I hope you guys have a nice rest of the day, and we'll go ahead and end it here. Thank you.
Thank you. Bye.
Bye.
Thank you. Bye.
Thank you.